Hi, my name is Tia Williams and I'm Director of Content Production here at A Cloud Guru. As you may have heard by now, A Cloud Guru acquired Linux Academy in December of 2019. This has allowed us to combine the best of two first-class learning platforms and expand the catalog of courses and features available to you. This course was originally published on A Cloud Guru. As we integrated content across our platforms, we tried to be as uniform as possible so you can find your courses and labs easily. You'll find that although the look of the site is different, the course content you came here for is where you expect it to be. As we continue on this journey together, we'll continue to publish all new courses and labs on both platforms to be sure all of our students get the best of both worlds. Eventually, everyone will use a single site as we continue our integration. Keep an ear out for updates via announcements, social media, and email over the coming months. We want to welcome everyone to a brand new world where the combination of our platforms gives you access to the most effective, hands-on, and comprehensive cloud learning catalog around. Thanks for watching, and we wish you the best in your learning journey.
Hello fellow Cloud Guru, and welcome to this certification course for the Azure AZ-900 exam. There's a new generation of Microsoft certification exams that have been designed to be more relevant to the actual job roles in the workspace that has to do with Azure. In other words, the basic cloud knowledge you need in your daily job will align better with the knowledge needed to pass the exams. This course is for the exam to achieving the Azure Fundamentals certification. In this first chapter, I will go through the following topics to get you started on your cloud journey with Azure. A course overview to give you an insight into the course outcome. This includes both the content of the course as well as what a Microsoft certification can give you. An introduction to the Azure portal, which is one of the key tools you will need to get familiar with for interacting with Azure resources and products. An introduction to the Azure Command Line Interface, or CLI. This is a text-only way to interact with Azure resources. An introduction to Azure PowerShell. This is the most geeky tool which allows you to program scripts to manipulate Azure resources. Don't worry about it right now though, if that sounds completely strange. The hands-on lab will show you how to create your first free Azure account. It'll be amazing and free. So what are we waiting for then? Onwards! The Azure portal is probably the most common and initially the most approachable way to interact with Azure. In its most basic form, the portal is just a website. You go to the portal website, you fill in your Microsoft username and password and log in as you would on lots of other websites that have your profile on them. The portal gives you access to all your resources on Azure, and all features of Azure can be accessed through it. You can, using Microsoft's words, build, manage, and monitor everything from simple web apps to complex cloud applications in a single unified console. Some of the features that make the portal a great first place to interact with Azure includes personalize the portal with custom dashboards, colors, and metrics that are important to your workflow. Access control, you can choose who has access to resources with very great accuracy. This is important to manage and govern your Azure resources effectively. Cost management, keep a keen eye on the costs of both current and projected costs. The Azure portal has great tools to keep track of your cloud costs. Use the single portal, single login, and integrated console to control all of your Azure things. It is a one-stop shop for Azure management. One point that is both frustrating and exciting is the quick feature updates. The Azure team is always working on the next feature or bug fix, and most of the time you don't even notice, but sometimes you use a feature one day and the next day it has changed completely. So while you get new features fast, it can get frustrating when your cheese is moved. Don't move my cheese! The portal is available in some shape or form on multiple devices, and this includes of course the web portal and apps on both iOS and Android. So that's the portal. It is a great visual way to manage Azure resources, and you will be using it a lot. So make it your friend. The portal, it's your friend. Up next, another way to interact with your Azure resources. Welcome to the AZ-900 certification course. I am so glad you're here because this course is created specifically for you to start learning Azure and train to become versed in Azure Fundamentals. In this course, I will take you through each of the topics of the exam, which are Cloud Concepts, which focuses on the core benefits of using Azure, such as high availability and scalability. Azure Architecture, covering how the cloud platform is put together to work best for you. Compute, which is all about how you use Azure to run your applications, such as on a virtual machine, networking, and how each service on Azure can talk to each other and the rest of the internet. Storage is where you put all your data. There are different ways of storing it though. Database, which is a brilliant way to store your data and get it back out efficiently when needed. Authentication and authorization to make sure you only get the right users into your services. Solutions on Azure looks at some of the more complex scenarios Azure is great at providing for you. Security focuses on the various parts of Azure that help make it the most secure choice for your business applications and functions. Privacy, compliance, and trust is looking at how services ensure privacy for your users and how you stay compliant with regulations and standards. Pricing delves into the various facets of how pricing is made up on Azure and how you can stay on top of the costs, because we want to do that. Finally, support outlines the many ways you can get help and assistance to using Azure, both from Microsoft and the wider community. And, of course, we also go through what to expect on the day of the exam. In true A Cloud Guru style, this course is engaging and keeps you on your toes. It isn't a simple dictation of facts you need to know, and I do my best to make it both an interesting learning experience, as well as putting each topic into context, so you can apply it to the real world as well. Throughout the course, I will explain some technical topics using non-technical scenarios to give you a better context for learning them. I'll be teaching you about Azure through theoretical lessons and hands-on labs, which are designed to give you a gentle introduction to getting your hands dirty using the tools millions of Azure engineers use every single day. So to give you the best learning experience I can, I've also included learnings based on personal experience and real-world scenarios where that may be relevant. At the end of the course, you'll have learned all the necessary fundamentals of Microsoft Azure, which won't just prepare you for the exam, but also prepare you to start using Azure in the real world. Cloud computing has a ton of potential, like a lot, and AZ-900 is the first key to unlocking it. So, see you in the next lecture really shortly. Now go do the course, go, quick! This is likely to be the first certification from Microsoft that you are studying for. After all, this is the foundational certificate for your Azure journey. I won't go through each chapter in the course, that is what the course website's for, but let's briefly go over what a Microsoft certification means and what it can give you. A certificate from Microsoft says that you are proficient in a specific role or technology and that you have passed rigorous testing in that particular area. But it's more than that. Yes, you will get a certificate to prove you have passed, but you are also sending a message to companies and the industry in general that you have certain skills and expertise. You may already have the skills, but without the certification, it is a lot more work to prove or convince employers and clients of that fact. It provides instant credibility. There's more though. When you pass your first Microsoft certification exam, you automatically join a network of other certified professionals. Having access to resources that you can share with a huge group of people in the same situation and with similar qualifications is extremely valuable. It can provide connections and opportunities, and new paths will open if you choose to follow them. You get access to more benefits, such as your own member portal with access to scores, certificates, offers, and more. There are resources for getting the most out of your certificate, and you can even let potential employers see a direct transcript of your achievements. You can also book new exams and get information of any changes to certifications and new certificates that could be relevant to you. With certifications come a confidence that you know you have the skills and expertise included within the curriculum of that cert. This will often lead to more output faster. Your productivity will increase and your efficiency will improve dramatically. You'll remove a lot of doubt of choice, of direction, and technology. To summarize, a Microsoft certificate tells the world that you are proficient in a certain area, it makes you more employable, it often leads to a higher salary, and it gives you the confidence believing you have the right solution for a particular scenario. Alright, let's talk about course outcome. Obviously, the main objective is to get you the knowledge and confidence to pass the AZ-900 exam, but there's a lot more than that. Passing the exam is one side of things, but A Cloud Guru also gives you the tools to succeed in whatever position you're in, where cloud technology knowledge is needed. The exam confirms that you know certain topics and tests mainly the what and the how, but it rarely provides context for the why and when to use the various topics we will cover. The outcome for this course is not just to convey knowledge because you have to learn a curriculum and study for the exam. It is more importantly to provide context for the lessons to give you not only the tools in the toolbox, but also the blueprint to how they can be applied in real life. Taking a certification course from A Cloud Guru is not an exercise to only pass an exam. It is a preparation to work with the tools, technologies, and products in your real world. Now, next up, we look at some Azure goodness in the various tools available. Now, let's welcome, me, to the stage to explain what the Azure CLI is and also the Azure Resource Manager. Fancy a coffee?
I want you to meet my best friend in Azure world, the Azure Command Line interface. To get slightly technical for just a minute, let's cover in broad terms what happens when you make a selection, change, or button press in the Azure portal. Say you want to create a new virtual machine. And let's say this cup of coffee right here is the virtual machine. There are multiple ways that you can create this virtual machine or cup of coffee. You could use the Azure portal. You select the resource, you fill in the details, and you click submit. This is like pressing a button on the cafeteria coffee machine, like here. And voila, you have a cup of coffee. Then there is the Azure CLI, which let's say is, well, this plunger here. It looks very different, but in the end, the same result, a cup of coffee. Just like the CLI looks very different from the portal, because it is a text-only entry tool, also known as a command line interface. An interface you only type commands into. Makes sense, right? So the end result is the same as using the portal though. In the CLI, you use a command like AZ-VM create, all typed out, to create a VM. In the portal, you use the mouse to select the options. It's just another way to make the same cup of coffee, whether you prefer to press a button, use a plunger, or maybe even hire a barista. It's completely up to you. You end up with a cup of coffee. There are of course other ways that you can make a cup of coffee or create a VM, such as through the various developer interfaces or coffee machines, but that is further than we're going to go in this lecture.
The CLI is a tool used a lot by Azure professionals for a few reasons. It doesn't change. The text commands stay the same and can be reliably reused. The commands are structured very logically, so once you know the structure, you can pretty much use all of the commands sort of by guessing. It is cross-platform, so it works on Windows, Mac, and Linux. Because commands change rarely, you can automate actions using the Azure CLI commands. This is really handy when you have to do the same thing over and over again. And it is easier to keep track of who did what with the CLI commands as you can log them, use source control, your Jira task, or any other project management tool. So it's a great idea to be familiar with the CLI even if you plan to use the portal for most things. You install the Azure CLI by a simple download from its website. Check out the resources for this lecture. Alright, next up, another tool. The final tool you need to know about is PowerShell. Just like the CLI, it is all written text and also considered a command line interface, and it can definitely be daunting to start using it. It can often be found pre-installed on your Windows machine, and if not, it is a simple install to get it up and going. It's like starting any other application on your computer. PowerShell is a command line interface as well, and it is text-based 100%. PowerShell lets you use something called commandlets, which are small, lightweight groups of commands called a script usually that you can use. For example, if you want to create a new virtual machine, you can use the commandlet new-azvm with the name of the virtual machine and a few other details, and PowerShell will create a virtual machine. In fact, PowerShell also talks to the Azure Resource Manager, just like the portal and the CLI. The exact same action happens behind the scenes to create your virtual machine. PowerShell can be used for many other tasks and platforms than just Azure, and it even has its own language. Azure professionals often choose to use PowerShell for interacting with Azure, as they are already using it for other tasks. PowerShell often fits nicely into an already existing workflow, so it's just another area of commands to learn. If you've never seen PowerShell, it is worth opening and getting a feel for it. For this exam though, you won't need it much, but you must have some basic knowledge of it. Use the resources on this lecture to learn more about PowerShell if you want to. This first chapter went through the background for the certification and some of the tools you'll need. So what did we cover? The course overview covered some of the benefits of certification and how the course is structured. As you might have guessed, this course will cover everything needed to help you pass the AZ-900 exam. To give you an introduction to Azure, you first learned about the Azure portal. It is a one-stop shop to manage all of your Azure resources in an intuitive, visual way. The Azure CLI is a text-only command line interface for managing all your Azure resources. It is a stable and structured approach to managing and automating how you work with Azure. Next up, PowerShell is a loved tool by many professionals, and Azure has a set of modules and uses commandlets to let you work with Azure itself. PowerShell is great for scripting and fits into a lot of workflows. A combination of the portal, the CLI, and PowerShell, Cloud Shell is a great tool for on the go, accessible from anywhere and with lots of included tools and features such as storage. And that's it for this chapter. Join me in the next one for some core cloud knowledge. Concepts of cloud computing can be quite different to traditional computing, which often includes owning many servers, buildings, cables, and employing people to manage it. This chapter goes through the basics of what it means to use the cloud, including the following topics. The language of cloud computing. Key terms are necessary to grasp and understand to have a meaningful conversation about cloud computing. Get an understanding of high availability, fault tolerance, disaster recovery, scalability, elasticity, and agility. Similarly to cloud computing language, the cloud economics language is important as well to understand why cloud makes business sense. In particular, you need to know the capital and operational expenditure definitions. Cloud service models are important to understand to choose the right services. You learn about infrastructure, platform, and software as a service, and then serverless. Is it really serverless? The Azure Marketplace provides an extra layer of functionality for your cloud applications. And then finally, how you architect the cloud depends on one of three models or approaches, public, private, or hybrid. So let's get stuck into it. What do you get if you cross the Azure portal, the Azure CLI, and PowerShell? No, not an imploding universe, but something called the Cloud Shell. Azure Cloud Shell is an interactive browser-accessible shell for managing Azure resources. It provides the flexibility of choosing the shell experience that best suits the way you work. And by shell experience, I mean you can use the fully dedicated standalone browser version or the portal component to choose either a bash experience, very similar to the Azure CLI, or a PowerShell experience, which is very similar to your standalone PowerShell instance. There are a bunch of features which can make the Cloud Shell really appealing and useful too. These include access to the Cloud Shell from the web, on your mobile app, and virtually anywhere that you have an internet connection, of course. It is authenticated and 100% secure. Choose either a bash or PowerShell environment depending on what suits your workflow. Bash is using the Azure CLI commands. Commonly used tools are included by default, such as Linux shell interpreters, PowerShell modules, Azure tools, text editors, build tools, and much more. There's also language support for Node.js, .NET, and Python. The Cloud Shell has its own storage, so you can store files and session data. This means you can persist your workflow across sessions and devices. And there's even an integrated file editor. So Cloud Shell is an excellent tool for on the go, or if you need to access Azure right now, wherever you are. A major business reason to use cloud computing and infrastructure is the costs associated. There are a few terms that are crucial to understand to get the right idea of how cloud pricing works and why cloud is so cost effective. Capital expenditure, or CapEx, is defined as money spent by a business or organization on acquiring or maintaining fixed assets such as land, buildings, and equipment. In our scenario, that could be buying more servers. Operational expenditure, or OpEx, is an ongoing cost for running a product, business, or system on a day-to-day basis. This includes printer cartridges and paper, electricity, and even yearly services like website hosting or domain registrations. In our scenario, that could be the power to run the servers. When it comes to cloud ROI, return on investment, comparing CapEx to OpEx reveals the cloud is a great way to switch IT spending to a pay-as-you-go model and reduce CapEx costs, as well as reap other benefits. Traditional models of having large, privately owned data centers required companies to make big CapEx investments to set up servers and other infrastructure. With cloud computing services, much of this can be moved to OpEx as a much smaller pay-as-you-go cost. This can have significant effect on the way accounting is carried out for a business. Although there is an entire chapter on pricing in this course, it is important to cover some of it in the context of cloud economics. While a lot of Azure is priced on an hourly basis, such as turning a virtual machine on, the consumption-based pricing model is critical to get the most bang for your buck. You pay for the resources you use, not the time it is on. It works like this. You pay for the resources you use, such as per execution of a function, per second of a resource usage, or a combination. For example, Azure functions are built based on per second resource consumption and executions. Consumption plan pricing includes a monthly free grant of number of requests and some amount of resource consumption per month per subscription in pay-as-you-go pricing across all function apps in that subscription. What consumption-based pricing means is that while you develop and start your product, hence with little traffic and usage, you don't pay much, if anything at all. This is a win-win, as you can use Azure resources without locking into any monthly expenses, and Azure gets you on the platform to see if their services fit your needs. A quick recap for you. Using the right budget structure for infrastructure in a company can make a big difference, which is also one of the reasons we are seeing such a huge shift to cloud computing. Capital expenditure, or CapEx, is when you buy something like a server. It's a one-time cost that is made upfront. Operational expenditure, or OpEx, is an ongoing cost to run your business, such as printer toner and electricity. This could also be your monthly costs for cloud computing services. Consumption-based pricing is a pricing model within Azure to let you only pay for the exact resources you consume. It's a win-win for both consumer and Azure. Alright, on to the next lecture. In this lab, we're going to set up a free Azure account. Now bear in mind, labs in this course are not mandatory. They are an addition to the content in the other lectures and will give you a better understanding of how Azure works. We need an email account to set up a free Azure account. I recommend for this course that you use a private email account. If you use a corporate email account, it could already have access to Azure and it may cause some problems. I am here on Outlook.com and I'm going to create a free Outlook account. I click the blue button, create free account, and I need to now choose a new email address. I'm going to choose AZ-900 and then I need to obviously choose a password. So type in your favorite secure password, click next. So I'm going to put in my name here, Lars Klint, and click next, and my birth date, and I can choose whatever I want here, and you can put in your obviously your birthday. My country is Australia, click next, and there's a bit of a captcha exercise here. We'll see if we can get this right. These are always a bit interesting. We'll see if that's correct. And Outlook's creating my account, so it looks like I got that right. And I now have a free email address that I can use to sign up to Azure with. So I'm going to open a new tab. I'm going to go to azure.com. And in here I can start free. So you can see the green button that says start free. And there's a few bits of information about what you get with your free account, which you'll always already have seen in the lecture on creating a free account. I'm going to start free. And this is where I sign up with the email address that I just created. So here I choose the email address I just created, AZ-900 by acg@outlook.com. Click next. And now we go through the whole sign up process for creating a new free Azure account. So I need to put in my email address again, even though I just did, AZ-900 by acg@outlook.com. And you need to put in your real phone number because it will be verified, which is good. You choose identity verification by phone, and I'll say text me, and I will get a text message on my phone that I will need to enter. And there it is. That was the code I just got here as well, and verify my code. So now Azure knows that I am me with that email address and that phone number. And then we do need to put in a valid credit card because we want to keep out, well, bots essentially. You can't just put in any credit card number. So I'm going to use one I have prepared earlier here, and you will have to put in a valid credit card of your own choosing. So once I've done that, I can click next, and it will verify that my details are correct for that card. And you then have to agree to all the terms and conditions for the Azure account, and you don't have a choice. So click agree, sign up, and you're now signed up to a free account for Azure. And that includes all the things that we went through in the earlier lecture. So now we're ready to start with Azure. So you click on the blue go to the portal button, and that will take you to the Azure portal. And this is where we'll be doing most of the work in all of the labs in this course. And again, remember, labs are not mandatory. They're here to expand your understanding of how Azure works. This is the first thing you'll see. You can have a tour, or you can maybe start later. I'm going to just start maybe later. And in the Azure portal here, you can see that you have several areas. On the left, there is all of the sort of shortcuts and the favorites to various services that are normally the most popular services to use. We start here with a quick start center in the middle, where there are certain wizards and guides to what you can do. And at the top, there is another bar which has a search, which we'll go back to in another lab later on in the course. And on the right here, you may remember in this chapter we talked about the Cloud Shell, which is the CLI and the PowerShell in the browser. That is this button here. Now, we aren't going to use the Cloud Shell in this course, but this is where it is if you need to find it and if you want to explore it on your own time. And again, you can choose Bash, which is like the CLI, or PowerShell in this case. We have a directory and subscription filter. So if you have more than one directory or subscription associated, so more than one Azure account with your email address, you could swap between them. There are some notifications. There are some settings for the portal, and then you can ask questions and get help and submit feedback. And that is pretty much the portal in a nutshell. You now have a free Azure account that we created with our free Outlook.com email address. And again, this is all you need to do to get access to all of the Azure services and the free credits and all the other free Azure services to get you started using Azure.
The Azure Marketplace is an integral part of the cloud platform. It offers technical solutions and services from Microsoft and their partners built to extend Azure products and services. It has all kinds of products and services such as SaaS applications, virtual machines, solution templates, Azure managed applications, and consulting services. Think of it as the App Store on your phone, but for cloud services. You have categories of solutions including base operating systems, databases, security, identity, networking, blockchain, and developer tools. All these can be accessed either directly through the Marketplace website, through the Azure CLI, or integrated with the Azure portal. You can add anything from the catalog to your Azure subscription, and you will be responsible for it. Some services are free, while others are paid offerings. If you're a Microsoft partner, you can of course also publish your product or service through the Marketplace, making it a distribution channel for your business. That's it, short and sweet. Up next is some cloud architect models. This chapter covered a bunch of important concepts when it comes to cloud computing. High availability, fault tolerance, disaster recovery, scalability, elasticity, and agility are terms frequently used in cloud computing. The first three relate to how stable and dependable cloud computing is. The last three conveys the ability to adapt really fast to changes in resource demand, user base, and application usage. CapEx and OpEx are the economic language of cloud computing. You learned that cloud computing with a largely pay-as-you-go model falls under OpEx, which is different budget and accounting section to CapEx. For some companies, this can make a big difference. IaaS, PaaS, and SaaS are cloud service models under which pretty much all the Azure products and services fall under. IaaS gives you full control of all the features of your infrastructure except for the actual hardware. You manage operating systems, networks, and application lifecycles. PaaS abstracts the platform-specific stuff like operating system and gives you a full platform to use, such as data warehousing. SaaS is a software solution that you pay a monthly rental to use, such as your email, accounting system, or payment facilities. The Azure Marketplace provides an extra layer of functionality for your cloud applications by letting users use and integrate third-party products and services. And finally, you learned cloud has one of three architecture models, or approaches: public, private, or hybrid. I hope you enjoyed this chapter and will join me in the next one. Getting an Azure account and subscription is one thing. Understanding the various models of cloud services is the next step. For the Azure Fundamentals exam, you have to know the differences between infrastructure, platform, and software as a service. You may have heard these terms before, but what do they mean in the cloud computing and Azure context? We start with infrastructure as a service, often just pronounced IaaS. Infrastructure refers to actual servers, being virtual ones, that are provided by Azure. It is as a service because you don't have to go out and buy physical servers. You can scale up and down quickly, provisioning more servers as you need them, and only paying for what you use. Whilst you don't manage any infrastructure, you do purchase, install, configure, and manage your own software, operating systems, middleware, and applications. On Azure, the IaaS offering includes virtual machines, storage, networking components, firewall, and the physical hardware everything runs on. Next is Platform as a Service, or PaaS. It is a superset of IaaS, and like IaaS, PaaS includes infrastructure, servers, storage, and networking, but also middleware, development tools, business intelligence or BI, services, database management systems, and more. PaaS is designed to support the complete web application lifecycle: building, testing, deploying, managing, and updating. On Azure, the PaaS offering avoids the expense and complexity of buying and managing software licenses, the underlying application infrastructure, and middleware.
You manage the applications and services that you develop, and the cloud service provider typically manages everything else. For Azure, this could be security features, development tools, and data warehouse services. Software as a service, or SaaS, is probably the most overused term when it comes to modern tech startups. It's a term that implicitly includes both IaaS and PaaS, and it is built on top of those. Normally it has to do with providing a service via a managed rented software service such as Stripe for credit card payments, Gmail for emails, or QuickBooks for accounting. You don't own the software, but you pay an access fee to use it, or it might even be free. That removes any maintenance you might have to do, and you always have the latest features. For Microsoft in general, their most common SaaS offering is Office 365. A strength of Azure is hosting and building SaaS applications using the features of the cloud platform. One last service model we should mention is serverless. Of course, this never means there are no servers involved in the solution. It means that you don't have to manage any servers. You are effectively using someone else's servers to run on, hence the term serverless. Azure Functions are probably the best known examples of serverless on Azure. It was the first genuine example of serverless on Azure. Serverless architecture takes PaaS to the most extreme by fully abstracting away the server in such a way that a single function of code can be hosted, deployed, run, and managed without even having to maintain a full application. For the exam, keep in mind that service is the core of Azure. That's why the platform exists. And there are three main ways to go about it, plus a new kid on the block. Infrastructure as a service, or IaaS, gives you virtual servers on which you can install what you like. You're renting servers, storage, network components from Azure. You manage everything except the infrastructure, which is a service. The next one is Platform as a Service, or PaaS. It's a superset of IaaS, but in addition includes middleware as a service. This could be developer tools or database management. PaaS is where a lot of the Azure benefits come into play for businesses. Finally, there's Software as a Service, or SaaS. This describes services built on top of IaaS and PaaS such as Office 365, Azure SQL, and more. You often pay a regular fee to use these. I'll end with serverless, which is becoming a bit of a buzzword but means you don't manage any servers anywhere in the food chain. A single function of code can be hosted, deployed, run, and managed on its own. Right, fancy some shopping? Azure Marketplace is around the corner. When discussing cloud architecture, there are three general models which are considered: private, public, and hybrid. Let's go through each. Private means that the services within the cloud are offered to selected users only instead of the public. The benefit is that an organization can create their own cloud they completely control, but get all the benefits of public cloud too. Private clouds generally have a higher level of security and privacy through both company firewalls and internal hosting. This makes it easier to ensure that operations and sensitive data are not accessible to third-party providers. One drawback, and it can be a big one, is that it is the organization's IT department is responsible for the cloud, not Microsoft. Private clouds require the same staffing, management, and maintenance expenses as traditional data center ownership. Public cloud is Microsoft Azure, Amazon Web Services, Google Cloud Platform, and many other commercially available cloud offerings. Anyone with an internet connection can instantly become a master of the service, overlord of the virtual machines, and emperor of cloud infrastructure. Unlike private clouds, public clouds can save companies from the expensive cost of having to purchase, manage, and maintain on-premises hardware and application infrastructure. The cloud service provider is held responsible for all management and maintenance of the system, for which you pay a low monthly fee. Of course, a public cloud can be accessed from anywhere in the world. It's kind of the point, right? On the flip side, you don't have any control over updates to features and specifically on which server your data is stored. You might have guessed what the hybrid cloud model is all about. Yep, it's a mix of private and public cloud. For a lot of companies, moving entirely to the cloud is not a simple one step. It's a tiered approach over a longer period of time to avoid disruptions and outages. And for some, certain services and applications just don't live in the public cloud. This could be for regulatory reasons, governance issues, or something else. A hybrid cloud allows applications and data to span both public and private cloud infrastructure. Organizations gain the flexibility and computing power of the public cloud for basic and non-sensitive computing tasks, while keeping business-critical applications and data on premises safely behind, for example, a company firewall. A hybrid model can alleviate some of the large capital expenditures associated with private cloud models and allow fast scaling for basic services. When it comes to downsides, the hybrid model can bring a lot of complexity. You'll have infrastructure in 2 locations, and while there are great tools to help you set it up, there are just a lot more moving parts. If managed correctly though, a hybrid cloud model really can be a best of all possible worlds approach. This final lecture covers some fundamental concepts you need to be across. Once you've chosen a cloud architecture model, it's very tricky to go back. Private cloud is exactly that. It's private. It's an incarnation of Azure that is hosted on your private hardware in a location you choose. A private cloud gives you full control over the services on it, with the benefits of a public cloud platform. You often get better security for your business. The downside is a lot of staff to manage and maintain it. Public cloud is Azure, AWS, GCP, and so on. You don't purchase any hardware, there are low monthly costs, but you have little control over the infrastructure. A hybrid cloud model lets you get the best of both private and public models, but you could end up with a very complex infrastructure. Alright, next, a short summary. Azure itself is made up of some fundamental building blocks. These building blocks are what makes up Azure and is fundamental knowledge you need to know for the exam. It is kind of what binds everything in Azure together. In this short but super important chapter, I will take you through the following. What are regions and what role do they play? What are paired regions and why is Azure so terrible at naming regions? How do availability zones work? How do they relate to regions and what purpose do they have? What are Azure resource groups and why are they so extremely critical to everything running on Azure? And finally, what is the Azure Resource Manager and where does it fit in the Azure architecture? Not a huge lot to cover, but it is fundamental to everything that comes after. If you have some experience or knowledge of programming, IT systems, computer infrastructure, or anything in between, you may have heard of or learnt terms such as server, integration, processing, data center, and more. While these are useful and worthwhile knowing, the language of cloud computing is a bit different. However, to be comfortable with the cloud and the services that are offered, you need to know and understand some of the language that is used to describe services and products. So hold on and get ready. In this lecture, we go through high availability, fault tolerance, disaster recovery, scalability, elasticity, and agility. These are terms that describe resilience and instant adaptability of cloud computing. First up is high availability, which is core to the cloud, including Azure. One of the issues with traditional servers, data centers, and IT infrastructure is that a company owns X number of physical servers placed in a data center or in the server cupboard in the office. While you can get your hands on the actual server, you are severely limited in actual number of servers. You have what you have. In a cloud scenario, you don't own any of the servers, none. But you can get more with the click of a button. This ensures high availability for your servers because if one fails, you can get a new exact copy of it in very little time. If your physical hardware that you own fails, you have to go and buy new hardware. High availability is a staple of cloud infrastructure and should be in any conversation concerning always available websites and other cloud apps. High availability depends on having a number of virtual machines set up to essentially cover each other in case one dies. This is done through a cluster, which is a group of virtual machines. High availability, though, is not max or infinite availability. As with high availability, fault tolerance is a term that is used to describe the resilience of cloud computing. Where high availability doesn't guarantee zero downtime, a fault-tolerant system does. As the name implies, the cloud system is tolerant to any faults that may occur. Tolerant meaning that any fault in the system that causes Azure services to fail are mitigated and dealt with by Azure itself. Kinda neat, and why fault tolerant is another key term in the language of cloud computing. In the same vein as high availability and fault tolerance is the term disaster recovery. While high availability and fault tolerance will deal with Azure outages, what happens in the event of a catastrophic disaster such as a hurricane, flood or tornado, a cyber attack or something else of that magnitude? Disaster recovery consists of complete plans to recover critical business systems and normal operations if such an event occurs. Disaster recovery is configured with a designated time to recovery and recovery point, which represents the time it takes to restore essential systems and the point in time before the disaster which is restored. So the first three terms we went through in this lecture all had to do with the resilience of cloud computing. Now let's go through how to describe having access to infinite resources, well, or as close to as you can get.
In cloud computing, scalability is the process of adding more resources on an as-needed basis. This is important because in a lot of cases you don't know when your users are using the system. At various times you can have an influx of users, which suddenly means that the current servers, being virtual machines or other services, will run out of resources to serve all those requests. So what would happen with traditional self-hosted hardware is that your servers would either, deny the requests or just fall over. Not ideal. So because Azure has a, perceivable infinite number of resources, such as servers, represented by this mug, when more traffic arrives to your application, Azure can add more mugs or resources. This is scalability. Azure can scale the use of resources with the needs of your application, service, or product. There are of course different ways that you can scale resources. Scaling out is adding more mugs to the pool of available mugs for your application. And these are all identical mugs. You can see that. But they get added real quick. So when the resource need goes down, the mugs are removed again. Of course, you can also scale up, and that is making current resources bigger. You can exchange a standard mug with a bigger mug. And you can of course also scale down. That is getting a smaller mug. Auto-scaling is when either approach happens automatically, according to rules that you've set. And this could be that every day at 9 AM you scale up, or if your CPU usage exceeds 70%, you scale out and get more mugs. So that's scalability.
So scalability is scaling out, up, or down, and doing so automatically to be completely capable of handling increased or decreased demand. It is one of the terms for describing how responsive Azure is to change in demand. Elasticity goes hand in hand with scalability and describes the ability to quickly expand or decrease computer processing, memory, and storage resources to meet changing demands without worrying about capacity planning and engineering for peak usage. You can say that elastic computing is what enables scalability. Agility when it comes to cloud computing relates to both the business and the computing context. In the cloud computing context, agility often refers to the ability to rapidly develop, test, and launch software applications that drive business growth. Cloud agility allows businesses to focus on other issues such as security, monitoring, and analysis instead of provisioning and maintaining the resources. So that was a lot of terms and definitions, and they're all very important to understand. So let's go over them again. High availability is the capability of several virtual machines to kick in and help process requests when needed. This ensures high availability of your application. Fault tolerance describes how Azure will ensure you have zero downtime for services provided by Azure. Disaster recovery means having a plan to recover a complete system in the event of a major disaster like a tornado or flood. This is done using time to recovery and recovery point metrics. Scalability is the ability to add or remove virtual machines, scaling out, or increase the resources on a single virtual machine, scaling up. Elasticity is the ability to quickly increase or decrease computer processing and resources. And agility means the ability to rapidly develop, test, and launch software applications. So up next, some economics in the cloud. Time to save some cash. Now that we've talked about hardware with regions and availability zones and the physical location of these, let's switch to the software side of Azure architecture. In particular, we'll go through resource groups and the Azure Resource Manager. Let's start with resource groups. These are essential for any architecture on Azure. Everything in Azure is inside a resource group, no exceptions. And while all resources must be inside a resource group, the resource group itself is not a resource. Think of it as a container that holds related resources for an Azure solution, and it includes those resources that you want to manage as a group. You decide completely how to allocate resources to resource groups based on what makes the most sense for your organization. A few key facts about resource groups are worth knowing. Each resource can only exist in one resource group. No exceptions again. You can add or remove a resource to a resource group at any time. You can move a resource from one resource group to another group. A resource group can contain resources that are located in different regions. For example, you could have a central database server in East US and your web application could be hosted in East US too. But they are in the same resource group as they are related. A resource group can be used to manage access control for administrative actions. You can give access to an entire resource group, including the resources in it. A resource can interact with resources in other resource groups. And even though a resource group isn't a resource itself, it still needs a location as it stores metadata about the resources inside it. That's data about the data. And that brings me to the Azure Resource Manager. In the introduction chapter, I briefly covered what the Azure Resource Manager is in relation to the Azure CLI. So let's have another look in a bit more detail. Azure Resource Manager, or ARM, is the underpinning of everything on Azure when it comes to creating, updating, or deleting resources. It is deployment and management services for Azure. The key thing to know is that if you interact with any of the resources on Azure, it goes through the ARM. Whether you use the portal, PowerShell, Azure CLI, REST APIs, or client SDKs, the Azure Resource Manager API handles your request. This also means that any functionality available or added to the ARM will be available in all the various tools within a shorter period of time. By Azure having a single entry point for managing resources, you get a bunch of benefits as well. You can deploy, manage, and monitor all the resources for your solution as a group, rather than handling these resources individually. When you deploy your resources, you can be confident it happens in the same way every single time. Your resources will be deployed in a consistent state. You can define the dependencies between resources, ensuring that any new resources don't step on the toes of the others. And you can easily decide which users have access to which resources using built-in features in the ARM. You can logically organize all your resources using the tag feature. Tagging is assigning a label for each resource you can then sort and perform actions on. And you can clarify your organization's billing by viewing costs for a group of resources sharing the same tag. So in summary, resource groups are what every resource in Azure is inside. While it isn't the resource itself, it is critical to manage your resources. It is completely up to you which resources you place in which resource groups. And it is an opportunity to structure how your Azure infrastructure is managed. Azure Resource Manager, or ARM, is the layer of the Azure architecture which every single interaction with Azure resources go through. Whether you use the portal, the CLI, or some other tool, it talks to Azure through the ARM. So thanks for sticking with me in this lecture. Now let's jump on up to the next chapter. This chapter covers a core concept of any cloud platform, and of course, that includes Azure as well. Compute. It's a term that covers any service in Azure that enables a computation in the cloud. In this chapter, we'll cover the following topics. Virtual machines. This is perhaps the most commonly referenced service in the cloud. We'll go through features, usage scenarios, and configurations of VMs. Leading on from VMs, scale sets are sort of a super user case of using virtual machines. We go through how they are invaluable in a lot of scenarios. What are app services? These multi-purpose services are extremely versatile, as you shall see. A brief introduction to containers, what they are and why you might want to use them with Azure Container Instances. And what you know about containers, how do you manage them? Using Kubernetes is one way, and we will look at Azure's offering. And finally, we go through the darling of serverless, Azure Functions. Learn why they're popular and how they're created, hosted, and run. Compute is essential to understand as a core component of Microsoft Azure, so let's get stuck right in. The main part of Azure that has an impact both on performance of your applications and services in relation to your users, as well as pricing, are regions. And hand in hand with regions come availability zones that are within regions. As defined by Microsoft, a region is a set of data centers deployed within a latency-defined perimeter and connected through a dedicated regional low-latency network. So let's go through what that actually means. A set of data centers means that each region has more than one data center. That is a physical location that has a large data center entirely dedicated to Azure. And there are more than one of those in a region. For example, East US has an official location of Virginia, but there will be more than one data center there. Latency-defined perimeter is a techie way of saying not too far from each other. Latency is a term used to describe the time it takes for data to travel. For example, if data from one data center to another takes 10 milliseconds, the latency is 10 milliseconds. It's that simple. Microsoft will have some internal limit to how far they want that latency to be, and meaning how far data centers can be from each other in that region. Regional low latency network again means not too far, but there is a clue here to the type of connection. Low latency network in today's money means fiber connection, which is the fastest connection we, as humans, know of, or at least on a production-ready level. So our paraphrasing of the region definition is 2 or more data centers not too far from each other connected with a fiber connection. Now that you know what a region is, how do you choose which region to host in? There are 3 main criteria to be aware of. If you know roughly where your users are and customers will be located geographically, you can choose a region close to them. You want as low latency as possible, meaning the data gets to them as fast as possible. Not all features are available in all regions. Regions that have come online more recently are less likely to have all the Azure products and services available. If you need specific features, especially ones that are not core, you will have a smaller set of regions to choose from. Pricing is different from region to region. For example, the price per hour for using a virtual machine can be higher by as much as 20 to 30% between regions. And at times you will have to weigh up if price, latency, or features are more important. Often you cannot have the best of all 3. Each region is paired with another region. With one exception, Brazil South, these pairs are within the same geographic area of the world. For example, East US is paired with West US, France Central is paired with France South, and Australia East is paired with Australia Southeast. The exception, as I mentioned, is Brazil South, which is paired with South Central US. Using Azure region pairs for multi-region deployments will ensure that in the event that the primary region experiences an outage, then you can fail over to the secondary region. In the event of an outage affecting multiple regions, at least one region in each pair will be prioritized for recovery. Across the region pairs, Azure serializes platform updates, plant maintenance, so that only one paired region is updated at a time. And some services such as geo-redundant storage also provide automatic replication to the paired region. Moving on from regions, the next level of architecture are availability zones. Availability zones are unique physical locations within an Azure region. Each zone is made up of 1 or more data centers equipped with independent power, cooling, and networking. And each region that supports availability zones, because not all do, has a minimum of 3 separate zones. The physical separation of availability zones within a region protects applications and data from data center failures. Looking at this from a higher up perspective, you have regions, and within those regions there are availability zones. Alright, here is me again.
To put the regions and availability zones into perspective, join me for some fun with Lego. Let's say this table here is a region. Inside the region we have these 3 availability zones. 1, 2, 3. Each of these zones are made up of 1 or more data centers, and each has their own independent power, cooling, and networking. There's a minimum of 3 separate zones in all enabled regions to make sure it is as resilient as possible. Now you might ask, resilient to what? Well, from complete data center failures. You still have the other 2 zones, that can serve your customers. Right. It didn't fall over. Of course, it requires your services to be in all availability zones for this to work. For virtual machines, for example, you have to specifically select how many zones you want it to be in. Having a virtual machine in only 1 of these zones won't protect it from a data center outage. You need at least 2, right? So these are the same virtual machine, you see, same number. Services like zone redundant storage automatically replicate across zones. If I add another bit to the storage like this, here, well, it gets added automatically to the other 2 as well, just like this. Zone redundant. Availability zones are part of the high availability approach in Azure that we covered as well in the Cloud Concepts chapter.
To summarize, an Azure region is a set of data centers that are close enough to each other that it doesn't matter which data center your data is in. You still get the same latency to your users. Latency is the time it takes data to travel. An availability zone is within a region, and each zone has its own separate power, cooling, and networking. You use availability zones to protect your data and applications from failures by replicating them between availability zones. Alright, onwards to the next lecture in this chapter. In this hands-on lab, we're going to create our first Azure resources, and we do that through the Azure portal, which is here. The Azure portal is the tool we're going to use for all of the labs in this course. The first thing we want to do is we want to create a new resource. There are a few different ways you can do this. you can either click on create a resource, which is kind of obvious, you'd hope. And that'll take us to this overview or wizard for creating new resources. And we can search for resources here up at the top. So if I wanted to create a new virtual machine, I could type virtual machine, and there would be some recommended resources that we could choose from in the drop down here. Another way to do it is up at the top here in the search bar. I can then here type virtual machine, and you can see that comes up with all the suggestions for services and the marketplace that has the virtual machine service. Or I can click on virtual machines if I want to create a virtual machine, and say we want to do that here on the left hand side in my favorites. Now the first thing we need to understand is resource groups. So let's create a resource group. Click on resource groups on the left here. Now a resource group is not an actual resource. A resource group is a container that holds other resources. Every single resource within Azure must be in a resource group. So we can add a new resource group by clicking on the add button, and that will bring up the wizard for creating a new resource group. So our subscription is our free trial. Give the resource group a name. We're going to call this ACGRG for resource group. And then we have to choose a region. And remember, a region is one of, at the time of recording, 54 different locations around the world. And I'm going to choose the Australia Southeast, because that's where I am. And that is the region where the resource group is going to be created. Now it has to live somewhere because there is data that goes with a resource group that explains what the resource group is and does. It doesn't mean you can't create resources from other regions in that resource group. I'm going to click review and create to create a resource group. My validation has passed, meaning I have valid properties that I've entered for this resource group. Click create, and it'll now create a resource group. You can see there, resource group created. If I click refresh on this list, we'll see that there is now a new resource group in this list. And there's our resource group. I can now place resources in that resource group. So let's go back to the virtual machine that we were selecting before. I'm going to click add to create a new virtual machine. And then we have to fill in the basic properties for creating a virtual machine. Choose the resource group that we just created, ACGRG. We have to give it a name, obviously. So we're going to call this ACG test VM. And we're going to place it in Australia Southeast. That's fine. As again, remember we can place it in other regions. It doesn't have to be in the region of the resource group. I'm going to choose a Windows 2019 data center because I like Windows. I need to give it a username and password for the administrator account. We call this ACG admin. And we need to give it a password for logging into the virtual machine. There we go. And now it's happy with the password. And then now I can click review and create. There are many more options you can select and change for creating a virtual machine, but that is not the object of this lab. So now it's been validated. All the information we have entered are correct, and we click create. It can take some time to create a virtual machine and have it deployed on your Azure infrastructure, but due to the magic of editing, you don't have to sit and watch that. And now our virtual machine has been deployed and created. So we can click on the blue button here to go to the resource and have a look at what we have just created. So here's the overview of the virtual machine ACG test VM that we have just provisioned or created. And there's a bunch of things we can see just off the bat here. We can see the status, it is running. We can see the location of it that we chose, Australia Southeast. There is a public IP address and a private IP address and so on. So all of the features and all of the properties of the virtual machine are available here from this portal, from the portal of the ACG test VM. Now we're not going to do anything with it. The scope of this lab was to show how to create a resource within a resource group, but we are going to clean up after ourselves. Meaning this VM is running, which means it is accruing a cost. It is costing money to run this VM. Not very much, but it is costing something, and it's coming out of our free credits that we got with the free Azure account. So a quick way to clean this up is to go back to our resource groups. When we created the virtual machine, other services were created along with it. So if we open up the resource group just before we delete it, you can see that the services within this resource group are many. There's a virtual network, a storage account, the virtual machine itself, a public IP address, network security group, network interface, and a disk. All of these services are required in order to run a virtual machine on Azure. But because we just created the virtual machine, all of these services were created automatically with it. Now, removing or deleting the resource group by clicking up here means that we're going to delete all of these services within it. And that's fine in this particular case. So we need to type ACGRG and delete. Click on delete, and that will then delete this resource group and the resources within it. And now our resource group has been deleted. So if we go back to resource groups, delete the second resource group that was created as part of the VM. And we need to type the name, Network Watcher IG, click delete, and we can get rid of that resource group as well. And now our second resource group has been deleted as well. So now we have cleaned up all the resources we have created as a test. So that means we won't have any cost for these anymore, and we can continue to use our free account. We start with virtual machines. When the cloud was new and innocent, the first service to take off was virtual machines. So what is a virtual machine, or VM? In its simplest form, it is a computer or server that you have access to exclusively. Why is it virtual then? Well, because it doesn't have its own exclusive hardware. There might be multiple servers or machines running on the same physical hardware. Virtualization of hardware is a common practice to get the most out of the hardware. Virtual machines are part of the IaaS offering on Azure. You manage everything except the hardware. You have complete control of what operating system to run, which applications to install, and how you maintain it all. Microsoft Azure will provide the networking for the VM as well. Compared to buying your own hardware and running your own servers, with Azure you get additional tooling to manage up to thousands of VMs. Use the Azure portal to control your hybrid cloud that could include virtual machines on Azure and on-premises. You can ensure virtual machine compliance with your company guidelines by using blueprints. These are templates for how VMs should be created. Azure will recommend improvements and changes to ensure high availability, security, performance, and lower costs. And virtual machines can run Windows or Linux in a large range of configurations and setups. And that leads us to pricing. And pricing can be very tricky to figure out for VMs. There's a whole chapter dedicated to pricing in this course, but let's briefly look at it in the context of virtual machines. Pricing for VMs is calculated hourly and depends on how much grunt you need. In other words, the more CPUs and amount of RAM you want, the more you pay per hour. Recently, there are new types of virtual machines being released that have dedicated graphical processing units, or GPUs, as well. These are great for artificial intelligence and deep learning scenarios. So when do you choose to spin up, that is the industry term for creating a VM, a new instance? Generally when you need to control all aspects of the machine. When you want to install a specific application on Windows or Linux and want to control its environment. And it could be because you have some existing infrastructure you want to move to the cloud and a VM makes it straightforward. On the flip side, if you use a different service on Azure, for example hosting a website with an app service, then you don't need a VM. Having your own virtual machine means you also have to maintain it, which, let's be honest, no one really wants to do. Virtual machines are an integral part of the compute offering on Azure, and they are widely used. For the exam, keep these points in mind. A virtual machine, or VM, is a computer you have access to exclusively. Buy, own, or control the hardware. Azure does. VMs are an IaaS offering where you control and manage everything on the machine. VMs managed by Azure gives you all of the Azure platform tools to manage them. And pricing for VMs go up as you increase RAM and number of CPUs. VMs are priced per hour. So up next, a way to use many VMs for providing high availability. Virtual machines and scale sets are IaaS parts of Azure Compute. Let's look at the PaaS part of Azure Compute, App Services. App Services are what is called a fully managed platform. This means that the servers, network, storage, and other fundamental infrastructure is all handled or managed by Azure. You just have to focus on your business value and logic. App services come in three main categories. The first one is web apps. These are your typical websites and online applications that Azure provides a managed platform for. They can run on Windows or Linux machines, and they support a large range of frameworks and languages including .NET, Java, Node.js, PHP, and Python on Windows, or .NET Core, Node.js, PHP, or Ruby on Linux. Web apps integrate well with other Azure and Microsoft tools as well, meaning developers find it very easy to deploy to them. They also support auto-scaling and load balancing, making them resilient and highly available. Terms you should now know are part of the cloud computing language. Web apps for containers let you deploy and run containerized applications in Azure. So what is a container though? It's a completely self-contained unit of software. All the code, programs, and applications that software relies on are all inside the container. This means you can deploy your applications anywhere and it will work. Think of it as the old Nintendo game cartridges. They came with everything you needed to play the game, as long as you had a Nintendo machine. A container comes with everything you need, as long as you can mount the container image, which is what web apps for containers can do. Containers make software run reliably between environments. The last type of web app is the API app, which is an efficient way to connect and expose any data backend you have. An API is an application programming interface, which means it is a software application that doesn't have any graphical component, meaning no user interface, no front end. It's an interface to connect other applications to programmatically. This is a very common architecture for companies to use to, for example, sell their data to clients. Azure API apps lets you host your API application easily. You can use a range of programming languages such as C#, Python, PHP, and Java. They come with a range of ways you can secure the access and the data, and they are easy to set up. In summary, app services are an easy way to host your web applications. It is a PaaS offering for Azure Compute, Platform as a Service. Web apps are your traditional websites and web applications. Web apps for containers are a way to host your existing container images on Azure. And API apps is hosting for your backend data service and doesn't have a graphical front end like the previous two app services. Next, we look at the new kid on the block. Now that you know what a virtual machine is, let's take that knowledge and go one step further. Scale sets for Azure Virtual Machines is it. Azure Virtual Machine scale sets lets you create and manage a group of identical load balanced VMs. That was a bit of a mouthful. The word identical is key here. You provide a single VM as a baseline for your scale set, and then you can create VMs from that instantly. You get clones of your VM to form your robot army. Well, VM army.
Let's talk about scale sets. I covered what scaling up and out means in the chapter on cloud concepts. Scale sets are closely related. Say I have a virtual machine, which is, well, this glass of water. You can see that it is half full. The CPU in the VM is running at 50% equivalent. If the CPU usage go up or more water is filled into the glass, as you can see, there'll be less space left. In a VM, CPU and memory usage can only go to 100%, just like I can't make the glass more than 100% full of water. So when the amount of water starts to get near to the top, meaning that your VM is starting to run out of resources, Azure will automatically add another VM from a scale set. This scale set is a pool of identical VMs, there's more here as you can see, that you have defined that are ready to go. So if you have 90% usage in the first VM, then effectively usage become 45% in 2, instantly, well almost instantly. When they start filling up, another one can be added as well. And when resource usage go down again, the VM or glasses will be removed automatically as well. Back to your scale set. In addition to automatically using the scale set, you can also schedule this scaling if you know the behavior of your application. Scale sets are a way to ensure high availability and application resiliency for your application.
Now that you know what scale sets are and how they work, let's go over some of the benefits for using them. It's easy to manage multiple VMs in a scale set. This is important for consistency in your application as you want the VMs serving your application to have the same configuration. Using a scale set allows your Azure infrastructure to work with a load balancer effectively. You will learn much more about load balancers in the chapter on networking. High availability. All the virtual machines in your scale set will run your application, so if there's a problem with one VM in your scale set, your customers will continue as if nothing happened. Auto-scaling. The demand on your application may change throughout the day, week, or month. To automatically match the demand, scale sets can add or remove VMs automatically. As an added bonus, you won't have VMs running unnecessarily as they are removed as well. Large scale. Run up to 1,000 VMs in a single scale set for those world domination scenarios. And there's no extra cost. You only pay for the added VMs, any storage, load balancers, and nothing else. With that in mind, imagine you're running an online store, and every day your customers will come and browse your shop and buy your items. As it is with online habits, your traffic usually increases in the evening and on weekends. Occasionally you'll have a sale and traffic increases further. And a part of your online store runs on a VM that processes some of the data. As demand increases, so does the data you need to process. If you were to scale manually and create new VMs when you needed them, you would forever be doing it. And to be honest, you probably wouldn't be very accurate. A scale set would be. It would monitor your usage constantly and make sure you both have enough resources, VMs, as well as removing them when you don't need them. In effect, it would make you more money and save you money. Win! Let's summarize this lecture on scale sets, which is taking virtual machines to a new height. A scale set is a number of identical VMs that can be activated or deactivated as needed. Use a baseline VM to grow your scale set. This is the VM you want your scale set to consist of, and it ensures the VMs are identical for maximum stability of your application. When more resources are used on one VM, another can help take some of the load. And there's no extra cost to running a scale set. You only pay for the VMs, networking resources, and storage that you use. Okay, so let's move on to the next lecture. Right over here. Come on. To try and mitigate some of the dependency madness that can happen when you want to run a piece of software on different environments, let me introduce you to containers.
Here I have a number of items. I have Nuge, a budgie. I have a spanner for the spanner. This is Delhi, obviously. There's a lollipop, a mouse, and some swag. Now, if I were to ship these just as is, I would have to find a way to secure them so they don't get damaged. Now, this would include maybe some rope, maybe crates, obviously, to put stuff in, maybe super glue. The issue is that for every single item, I have to come up with a solution on how to ship them. Everything becomes custom, which is slow and error-prone. This is similar to how software is traditionally deployed and set free. You build your software bundle and then hope it works on whatever device or shipping mechanism that is used. It is what spawned the ancient software developer mantra, works on my machine. Now for shipping, us clever humans then came up with shipping containers. Haha. A common standard where you put your stuff into. It doesn't matter if it is a budgie or a spanner or whatever, as long as you can fit it inside the shipping container, it can be sent. Like that. The shipping container comes with all the interfaces and dependencies to get it onto a truck, train, or ship. It's the same idea with containers on Azure and in computing in general. A container provides all of the necessary dependencies such as frameworks, other pieces of software, operating system interfaces, and much more. You put your application inside a container with all the dependencies and it will run on any machine. Now, because containers are relatively small, you can have lots of containers on the same machine or the same ship. Think of your virtual machines as a ship that can hold lots of containers, and each container is a single self-contained application. There's 4 applications.
Containers are an important part of modern cloud computing. So to recap, using containers means you can manage dependencies with confidence in containers. All the dependencies your application has on other files and processes are included in the container itself. Less overhead compared to full-blown virtual machines. Containers don't have any operating system components. Increased portability. Applications running on containers can be deployed easily to multiple different operating systems and hardware platforms. Containers are much more efficient when it comes to the development lifecycle of deploying and maintaining them. Scaling and patching containers is much simpler as well. Operation teams know applications in containers will run the same, regardless of where they are deployed. Consistency is your friend. So how does this look in practice? What is the workflow for using containers on Azure? You develop a software application as normal. You go through the various cycles of creating your application. When you are ready to publish it, the application gets wrapped up in a container image, which can then be deployed or published to something like Azure Container Instances, also called ACI. And that is the service you can be tested on in the exam. With the knowledge of what containers are in computing, let's look at ACI. Azure Container Instances is the primary service on Azure for hosting and running your workloads in a container. Workload is another word for process, application, or any other compute function you might have. With ACI, you can run your containers, meaning run the application inside of the container, without managing any virtual machines. You can use containerized applications to process data on demand by only creating the container image when you need it. Spin up the instance, process your data, then shut the container down again. This will both save money and resources. And this is all done through the Azure portal, the Azure CLI, or PowerShell. It is quick and relatively simple to use. So next up, let's find out how we can manage lots of containers in Azure. We've covered both the IaaS and PaaS of Azure Compute. So let's move on to a third architectural approach, serverless and functions. But what are Azure functions? The easiest way to understand it is to compare to something we know, IaaS and PaaS. On a virtual machine, you install your own applications and programs. You have access to the operating system, and you can see all of the resources available to you. For Azure App Services, you have a web application running and you can monitor the whole application. You don't have access to the machine it is running on, but you can see the processes and other details. An Azure function is the smallest and lightest compute service on Azure. As the name implies, it's a single function of compute, a single action that happens when its unique web address is hit. When an application or user on the internet calls the Azure function or invokes it, it is done via a web address. This unique address triggers the function, which then runs once and processes the request. It can talk to other Azure services, call more Azure functions, provide a reply, or something else. Once the function has finished, that is it. Nothing else happens until it's called again. A function just does one run and one unit of compute. So how do they work then? Functions still use a virtual machine to run on. After all, the compute has to happen somewhere. But you don't have to worry about the maintenance, processes, or anything else. It's a serverless compute service. You just have to focus on your functionality. So let's say your funny ferret business lets users upload pictures of their critters. These images need processing to both optimize them for web display and storage. When a user uploads an image of their funny ferret through to your website, an Azure Functions receives that image. Oh, it's not funny enough? You say, well, okay, there you go, fixed it. The function has just one job to do, which is process the image to compress it and turn it into the correct file format. The function then places the image in a database for future use in your online application. Then the function dies. So what is the advantage of this setup? Why use a function specifically for this? For a few reasons actually. Your function will only run when images are being uploaded. If you have no traffic and no images, then you have no resources running. And if you have no resources running to process images, then that saves you money. And if for some reason your function fails while processing an image, that does not affect the processing of all the other images being uploaded and treated in different functions. You spread your risks in the application. At A Cloud Guru, our entire platform is serverless. We don't run any VMs anywhere. That's enabled great growth and great flexibility to serve our large catalog of courses to a huge audience. And we continue this trend and journey as we grow. So next up, we'll go through a short summary of this chapter. There can be no cloud computing without networking. In fact, there can't be any computing of any significance without networking. It is so fundamental to any form of computing infrastructure that you need to get a good grip on the main Azure networking fundamentals. So in this chapter, we'll go through the following networking lectures. What is a virtual network and how do they fit into the Azure architecture? When can you use a load balancer and which problems can it solve for you? What is a VPN gateway? How can it fit into your architecture and when should you use one? How is an application gateway different to a load balancer and which applications can use one? And finally, an Azure Content Delivery Network, or CDN, can be a valuable piece of your Azure network, but what is it and how does it work? All of this networking goodness coming up in this chapter. Plug in your LAN network, sit back and enjoy, but not too much. Gotta learn as well. When you want to manage many containers at the same time, it can get tricky if you had to only use the Azure portal or CLI. Enter Azure Kubernetes Services. Yeah, first of all, I know. Kubernetes, right? What a name. Most services on Azure are named after what they do. Virtual machines, SQL Server, Key Vault, and many more. Kubernetes does not fit that mold. Kubernetes is Greek for governor or captain, and that is also why the logo is a ship's wheel. It was conceived by Google, hence the non-Azure name. Sometimes it's also spelled K8S, still pronounced Kubernetes though. Probably because we need more abbreviations. Oh, you're asking why that name? Well, according to the internet, this is how it was named, as told by one of the founders. We had 13 other names we couldn't get past Google's legal department. It was the last day and I had to pick something. I was driving into work and I thought, well, the technology is like driving a container ship. What would the helmsman or captain be called? So I tried to find something exotic. I had no idea what the Greek was for that. I had to look it up. Named like all good tech, at a whim, using Google. Now, it is an open source container orchestration system for automating application deployment, scaling, and management. Yeah, let's break that one down. Open source means that the code base is public and anyone can submit fixes and feature ideas to the product. This is great because the community using the product get more involved and invested in it. An orchestration system is a system that keeps track of lots of moving variables and features to produce a specific and desired outcome. Kubernetes makes sure that all your containers are set up correctly, file systems, objects, and everything else is working together as well. Automatic application deployment means that Kubernetes will manage deploying more instances of your container images as you need it. This could be when demand for the application increases and a single instance can't handle it. Automatic scaling refers to Kubernetes automatically monitoring the load on your container instances and determining when to scale them to manage the increasing or decreasing workload. Neat. So Kubernetes has a lot of features, and those I just mentioned are core to the product. In addition, users choose Kubernetes because it allows you to replicate architectures that involve containers. You can reuse a setup over and over again once you know it works. When it comes to Azure, Kubernetes lives in the cloud. Azure Kubernetes Services, or AKS, is a managed service that comes with all the features I mentioned before when going through the definition of Kubernetes. Because it's managed and hosted by Azure, you also get the standard Azure services such as identity and access management, elastic provisioning, that's adding more resources as needed, integration with Microsoft coding tools such as Visual Studio Code, and global reach with supported Azure regions and on-premises installations using Azure Stack. So you might ask, where do the container images come from? Or how do I know which container images I can use? And those are great questions, and the answer is Azure Container Registry, or ACR. This is a service that keeps track of the current valid container images. The ACR manages container images and associated files known as artifacts using a fully managed Azure service. When your Azure container instances or Kubernetes services need to create a new container, the image comes from ACR. You can use Azure Identity and Security as well to make sure the container images are safe and sound. Imagine, for example, you have an application that processes some orders for customers. That application runs inside a container, which is created from an image in ACR. Azure Kubernetes Services manages the containers and has what is called a cluster. A cluster is a set of machines called nodes that run containerized applications managed by Kubernetes. So when the amount of orders increase and the current container can't keep up, Kubernetes can automatically provision another container to take some of that load. That's done in what is called pods. Pod is a group of one or more containers with shared storage network and a specification for how to run the containers. Your application for processing orders lives in a pod. So you have the Azure Kubernetes Services cluster. Inside that are some nodes, which are your computing devices, sort of like virtual machines essentially, and pods are hosted on these nodes, and each node has one or more containers which is used for the scaling exercise. Make sure you remember this diagram because this is part of what could be on the exam, all of these different terms. There you go. So Azure Kubernetes Services, it is a must for managing any kind of container infrastructure on Azure. All right, moving on. And that brings us to the end of this chapter. Compute. It is the most basic of Azure functions, so naturally, pretty much everything builds on top of it. Virtual machines, or VMs, is virtualized hardware that you control exclusively. You can spin up as many as you need, and you get rid of them when you don't need them anymore. The tools in Azure for VMs are many, and you get them all to help you manage your fleet of machines. You pay for VMs on an hourly basis, and there are a ton of different ones to choose from with various amounts of memory and CPUs. Scale sets are the next step up for using VMs. They are sets of multiple identical VMs that get created and deleted automatically to make sure your application is running optimally. They provide high availability and also protect against any server failures by shifting the traffic. App services provide a managed platform for you to host your web applications. You don't have to worry about VMs or managing any IaaS features. They come in 3 flavors: web apps for containers, and API apps. They all support a range of programming languages and operating systems. Azure Container Instances hosts and run your containers on Azure. Containers are an important part of modern cloud computing and can be maintained and deployed much quicker and consistent than on a virtual machine. Kubernetes is an open source tool that allows orchestration of many container images and applications. You use clusters and pods to both scale and manage the running of your applications in containers. Finally, Azure Functions is the serverless choice for compute. As the name implies, an Azure function is a piece of code that does one function, one task. All of ACG is built on serverless technology, functions being a part of that. Wow, another chapter down. Look at you, machine! Let's keep going. When you have more than one VM serving the application, how do you decide which VM gets a particular user? A load balancer is the answer. Imagine this scenario. Your online business for booking removals of angry llamas is going super well. You're starting to get much more traffic than you originally anticipated. The VM that you use for processing some of the order data is getting overloaded at times. You add a second VM, but how do you now manage the traffic flow and use both? Adding a load balancer in front of the 2 VMs to capture the traffic before it reaches them means you can manage where the traffic goes. As Microsoft puts it, load balancer distributes new inbound flows that arrive on the load balancer's front end to backend pool instances according to rules and health probes. So let's break that down. Inbound flows is any kind of traffic, whether from the internet or from a local VNet. Any inbound traffic will be received by the load balancer. The load balancer's front end is the gatekeeper of all traffic to the VMs it manages. In effect, whoever calls the service the VMs are running only sees one access point, which is the load balancer's front end. Backend pool instances are the VMs that are receiving the traffic from the load balancer, and rules and health probes refers to the load balancer rules for directing the traffic. More on that in just a sec. A health probe is a service that makes sure a VM is ready to receive traffic before the load balancer sends any. This ensures the load balancer always sends traffic to a healthy VM. Some of the scenarios where you would apply a load balancer includes load balancing incoming traffic, as we went through in the example at the start of the lecture, load balance traffic from internal networks across both Azure and hybrid scenarios, port forwarding of traffic. You can forward traffic to a specific port on a specific machine in a backend pool, and a port is a way to specify a specific process. Each process on a computer listens for traffic and messages on one or more ports. A load balancer can also provide outbound connectivity for the VMs in the backend pool should that be necessary. Alright, load balancers, done. Let's move on to the next lecture. So let's look at how we can create an app service and an app service plan for that matter. On the left here is app services, click on that. And this will again give you a list of all the app services that you have currently, which is none. So we click add to add a new app service. And again, an app service is a way to host content on the web. Usually this is a website, but it could also be a mobile site or something else. So we have a free trial. We need to create a resource group because if we use the dropdown, we can see we don't have any. We can create a resource group from this screen as well, which is handy. We're going to call this ACG app service, like so, if I could type, and click OK. And we need to give this a name. We can call this test lab ACG app. And this name has to be unique across all of Azure websites and Azure app services. So we can't just choose the same one over and over again, because this will get its own unique internet address. Then we need to choose a publish method and a bunch of other things that we'll just keep as default. We're choosing a .NET Core, which is a type of programming, and we need to choose a region. And this region we're going to choose as probably Australia Southeast, because that's where I am, so why not? Now further down, you can see it says App Service Plan. You create an app service, and that is always within an app service plan. Think of the app service as the website, and the app service plan as the server. So you have a server to host your website, and you can choose different types of app service plans or servers. Click on change size, and it'll bring up a little picker here, a spec picker, and I can choose what kind of machine I would like. And there is a whole bunch, and it depends on how much throughput, so that is how much power, computing power and memory you would like to have on this server or app service plan. And of course, the higher one you choose, the more it's going to cost. And in this case, you can see up here there's a dev and test. I'm going to click on dev and test, and there is even a free one, which is on shared infrastructure. That means you share a machine or an app service plan with other people. That is good if you just need to do a quick test or a quick proof of concept to put something up on the internet. It is not recommended for anything production, obviously. We can choose the shared infrastructure for a free one, or we can do a D1, which is a very, very small machine. And you can see you get estimates on cost per month as well. This one is $18.04 Australian per month. If I go back to production, clicking on that tab, I'm just going to choose the one that Azure recommended, the S1, for this particular example. So apply that, and we now have a new app service plan called ASP-ACG App Service-9D50, which is just the name that Azure has come up with. It doesn't really matter what it's called, but we can give it another name if we choose to. By clicking on Create New, we can give it a name, and we're going to call it ACG Test App Service Plan. And it's okay with that. So we click OK, and that's now the name for it instead of the one that Azure came up with. And I can then just click Review and Create to choose the rest of the settings as default. And again, we're not looking at all of the settings for app services. We're just going to look at how to create a simple app service with an app service plan. And this has now been validated, so I can click Create, and that will create my resource. And you can now see that we get little messages initializing deployment, and this will also tell us when it is finished. And now our deployment is complete. We have created a app service on an app service plan. So again, we can click on Go to Resource to have a look at what this app service looks like. And we can see there's a bunch of stats as well. This will show us if someone is actually on the server, which obviously they aren't right now. And we have a unique URL. So that is the website for this particular website or this app service. So if I go and I open this in a new tab, and I go to that tab, you can see that we actually have a website running. This is a default website. This is what Azure shows if nothing has been deployed to this website. It says your app service is up and running. So this is a good way of just confirming that we have an actual running app service plan, an app service on an app service plan. Close that tab. And there's a bunch of other things that you can configure, but again, that is not the scope of this lab. We have now created an app service on an app service plan. And the important thing to take away is that we have many different types of app service plans or servers on different sizes, depending on what you would like to use them for. And you can host multiple app services on a single app service plan. It's a good way of saving money. And again, this is all part of cloud. We're using a single resource and utilizing it as much as possible by deploying many app services to it. So again, another resource we've created, and let's go and then clean it up so that we don't rack up costs on our free account. So go to the resource groups, and we're going to delete this app service resource group here. So ACG, app service, and we're going to delete that. And this one, then again, delete everything that's inside of this resource group so that we don't rack up any costs for any of the products that we've just created. And our resource group has now been deleted, and we have cleaned up after ourselves, making sure we don't incur any additional cost to our free subscription. When you want to securely communicate between your Azure resources and your on-premises network, what do? Well, you use a VPN gateway, of course. Before we get into the VPN gateway encryption magic, let's start with a virtual network gateway first. A virtual network gateway is composed of two or more virtual machines that are deployed to a specific subnet you create, which is called the gateway subnet. Remember, a subnet is a dedicated part of a VNet that has a specific range of IP addresses it can use. The VMs that are located in the gateway subnet are created when you create the virtual network gateway. A VPN gateway is a specific type of virtual network gateway that is used to send encrypted traffic between an Azure virtual network and an on-premises location over the public internet. Let's say you have an established company that has its own on-premises infrastructure. This is working well, but you are wanting to move parts of your system to the cloud to take advantage of the cloud goodness such as scalability, high availability, and costs reduction. This means you'll have a hybrid solution with some of your data on premises and some on Azure. In order to communicate securely between the two, you create a VPN gateway, which is a specific kind of VNet gateway. A VPN gateway is a key part of having a secure and available hybrid cloud architecture. There are various ways to connect your on-premises servers with the VPN gateway, but that is outside the scope of this course. You should know the main three components of a VPN gateway setup though. An Azure VNet with a VPN gateway attached. This gateway will have its own public IP address. A secure connection called a tunnel, which has one of a number of encryption mechanisms. An on-premises network with a complementary gateway that can accept the encrypted data. And this is called a site-to-site connection. You can also have one VPN gateway with more than one on-premises network connecting to it. This is called a multi-site connection. For the exam, you need to know about VPN gateways, as they are critical for efficient cloud computing in a hybrid architecture. A VPN gateway is a specific kind of VNet gateway, which is two or more machines deployed to a specific subnet. A VNet gateway of type VPN becomes a VPN gateway. And a VPN gateway is used to send encrypted data from Azure to on-premises. There are three parts to a VPN gateway use case scenario. Azure Gateway Subnet of two or more machines, a secure tunnel for data to be transmitted, and an on-premises gateway to connect to as well. Up next, a different type of gateway. The most fundamental part of the Azure private network for your infrastructure is a virtual network. A virtual network, often called a VNet, enables many types of Azure resources such as Azure Virtual Machines or VMs to securely communicate with each other, the internet, and on-premises networks. A virtual network is virtual because while you get access to it, you don't have any access to the hardware. Just like a virtual machine, it is yours to use, but the physical hardware is hidden away. It is abstracted. Before we get more into virtual networks, let's first cover the idea of an IP address. Let's compare it to sending a letter. In order for this letter to arrive at the correct destination, you write an address on it. And when you put it in the mailbox, the letter is processed and sent to the correct address. An IP address has the same purpose on the internet. Every piece of internet traffic, such as requesting a website, will have an IP address which ensures the traffic gets to the right server on the internet. In effect, a VNet is similar to a traditional network that you'd operate in your own data center. There are four main concepts you need to understand when it comes to VNets. So let's go through each in detail. An address space is the range of IP addresses there are available. An IP address is like a street address for a house, as we went through before, designed to uniquely find the resource. Every service or resource that is connected to a VNet will get its own unique address on that VNet within the address space. That is how services on the same VNet can find each other and communicate. You assign an address space to the VNet, and each connected device, service, or resource automatically gets an IP address assigned in that address space. Subnets enable you to segment the virtual network into one or more subnetworks and allocate a portion of the virtual network's address space to each subnet. Doing that, you can have multiple networks on the same VNet. So why would you do that though? Well, it makes it easier to keep track of which services go together. Address allocation is more efficient, but probably the most important reason is that you can secure individual subnets using a network security group. We will cover those in the chapter on security. Every VNet belongs to a single region. That means services and resources on a VNet must all be physically located in the same region as the VNet. You can connect VNets though to communicate across regions if need be. Each VNet belongs to a single subscription. Each subscription can have more than one VNet though. The advantages you get from using a cloud-based network compared to a network in your own data center are significant too. They boil down to terms you should be familiar with by now. You can scale a VNet to suit your needs with a click of a button. Because VNets are a core part of Azure, they also benefit from scaling. If you suddenly need more addresses in your address space, it is a simple exercise to add more. If you need a brand new VNet, that is a simple action too. VNets ensure high availability for your resources. This can usually happen through peering VNets, which is connecting two VNets using a load balancer or through a VPN gateway. The last two services we cover in this chapter too. You can isolate services and products very efficiently and simply with VNets. Using subnets and network security groups, you can manage and organize your resources within a VNet. A VNet is a fundamental part of Azure and connects all your resources and services. An address space is the range of IP addresses available to assign to resources on that VNet. Subnets let you segment a VNet into smaller networks that make logical sense. Subnets can also be secured individually. Each VNet belongs to a single region and a single subscription, and VNets embrace the same cloud attributes as other core services: scaling, high availability, and isolation. Next up, we balance a workload or two. What do you get if you take a load balancer and sprinkle a little cloud on it? An application gateway, of course. If you recall, a load balancer receives your internet and network traffic, and based on an IP address and a port, it will send that data to one of the VMs in the backend pool. But what if you want to route the traffic based on other parameters than simply IP address and port number? With Application Gateway, you can make routing decisions based on additional attributes of an HTTP request, such as URI path or host headers. An HTTP request is the data format that is received from any kind of internet traffic. The URI path is the web address for the request, and a host header is a piece of information that is sent with the request. This means you can send traffic from a specific web address to a specific machine. For example, if you have a request for a URL that is images, you could send that to a specific pool of machines that are better at handling images. The same could be done for videos. One of the great things about a lot of Azure services is that they work so well together. And for the Application Gateway, that is no difference. A few of the benefits for using an Application Gateway are that an Application Gateway can scale up or down based on the traffic that comes to it. As always, this can cost more, but it also means you don't have to worry about managing the resources needed to serve your application. An Application Gateway has end-to-end encryption for all traffic, meaning you can comply with any requirements about securing the traffic. If not needed, you can disable secure transfer to the backend pool to improve processing times too. Zone redundancy. This is an application gateway that can span multiple availability zones, offering better fault resiliency. And you don't have to set up more gateways to cater for each zone either. You can use multi-site hosting to use the same application gateway for more than one website. You can in fact add up to 100 websites to the same instance of an application gateway. This will both save you on cost and complexity. So in summary, an application gateway is another type of load balancer that works on a higher level. It works on the HTTP request of the traffic instead of the IP address and port. Traffic from a specific web address, such as an image or video URL, can go to a specific machine in the backend pool. It works well with other Azure services and can share the same cloud benefits like high availability and pricing. And it supports auto-scaling, end-to-end encryption, zone redundancy, and multi-site hosting, among other benefits. Alright, almost through this chapter. Come on, keep going. This chapter on networking covered more fundamental components of using the Azure platform. A virtual network is a fundamental part of any Azure architecture. You can't have an Azure service that isn't somehow connected to a virtual network. A VNet has several properties: IP address range, subnet, it's in a single region and a single subscription, and you can scale VNets quickly and they provide high availability too. A load balancer solves the problem of where to send traffic on a group of VMs running the same application. Based on IP address and port number, a load balancer will take incoming traffic and send it to a specific VM in the backend pool. Rules and health probes keep the load balancer and backend pool running smoothly. A VPN gateway connects your Azure infrastructure with your on-premises network. It is a specific type of virtual network gateway and is a secure way to connect your hybrid cloud solution. An application gateway is similar to a load balancer but can distribute incoming traffic based on HTTP request properties such as URL and host header values. This means traffic from the same session can go to multiple servers in the backend pool. A content delivery network, or CDN, stores a cached version of your application on edge nodes, which are servers close to the user. Your application will load faster and less traffic will hit your main server. When content changes, caches are invalidated and updated. Wow, another chapter bites the dust. So ready for the next one? Over here. Come on, we have chocolate. Anything to do with computing includes some form of storage. Storage of transient data, data that is used for a single session only, storage of user details, storage of orders, storage of customer data, and everything else. And Azure is no different. Well, no different in that lots of storage is needed. So in this chapter, I'll cover the 4 main ways to create storage on Azure. We start with blob storage, which not only sounds funny, but is incredibly versatile and used for a ton of different scenarios. Disk storage is just like it sounds, a disk for you to store your data on. File storage is a fully managed file storage in the cloud. It is a great way to extend on-premises storage. Finally, archive storage, which is a cheap way to store massive amounts of archived data. Storage is not the most exciting thing about Azure, but you have to get it right to make your applications efficient. Choosing the right storage type for the job is critical. Before we get into storage specifics, let's cover what a storage account is in general in Azure. The storage account is the unique Azure namespace for your data. This means that every object that you store in Azure Storage has a web address that includes your unique storage account name. The name you give the storage account becomes the main web address for it too. If my account was acloudguru, the storage namespace or address would be acloudguru.storagetype.core.windows.net. This also means that the name of your storage account must be unique across all of Azure, which can be annoying at times. The storage account is the base of all Azure storage types. Alright, let's get started. When it comes to world domination of your leisure llama rental business, you want your users to load your site and resources as fast as possible. And if your application is hosted in Australia and you have users from Paris, then they will wait a while to get that information. The fix is using a content delivery network. A content delivery network is most often called a CDN. It's a distributed network of servers that can deliver web content close to users. CDNs store cached content on what is called edge servers in locations that are close to end users to minimize latency. Let me explain.
Here's the internet. Well, it looks like a table, but it's definitely the internet. And here is the data center and service that is hosting your online store selling kits for making frozen yogurt. You have customers up here all over the world, but you have just the one location for your online resources, this data center here. So what happens when your customers from far away, like up here, wants to load your website? Well, it takes longer. They gotta send their dog or their data all the way down here and back again. And that's just to get the pricing on the Japanese apple flavor of frozen yogurt. And sometimes it takes a lot longer. So long they might eventually give up. Instead, what if they only had to request the data from the closest Azure data center to them? That is what the CDN does. It places copies of the data of your application on what is known as edge nodes. So here are 3 edge nodes. The edge of the internet, closest to your users, each of the 3 users. So now your users only have to go and get the data from close by, and everyone's happy. But wait, I hear you say, Lars, what if my website changes? I might update my prices and I want everyone to see that. Well, that is where caching and data invalidation comes in. So each piece of data on the edge node, which are these here, has an expiry date. Usually it is some hours depending on how often the data might change. So if your user goes to the edge node, or sends the dog, to get the data, and it has expired, meaning they have to get a fresh set of data, then they can request it from the master copy. And then they get a new cached version, like that. They take that back, that goes on the edge node, and then the user sees that. That's how a CDN works and makes your web presence global.
A CDN gives you global superpowers at a whim using leverage of the Azure infrastructure as if it was your own. The benefits of using Azure CDN to deliver website assets include better performance and improved user experience for end users, especially when using applications in which multiple round trips are required to load content. Large scaling to better handle instantaneous high loads, such as the start of a product launch event. A CDN will protect your backend from traffic hitting it as well. Distribution of user requests and serving of content directly from edge servers so that less traffic is sent to the origin server. Now, I've mentioned two terms in this lecture that could use some clarification. The first is a cache or caching. A cache is a collection of temporary copies of original files, such as a copy of an image. The cache's primary purpose in any computing scenario is to speed things up. For Azure, the cache is placed close to the end user, so the latency, which is the travel time of the data, is less. This makes, for example, websites a lot faster. A cached item can also expire, and at which point a new copy is needed. And that brings me to the origin server. This is the original place that your web application is stored. The origin server is the master copy of your files for your application. Next, let's go through what you learned in this chapter on Azure networking. First up is blob storage. It's one of my favorite words to say when it comes to cloud. Blob. What does blob mean though? Blob is a term used widely in technology for binary large object. In other words, pretty much anything made up of bits and bytes. These blobs of data are stored in containers inside the storage account. That means there are three layers to blob storage: storage account, container, and then blob. Let me explain blobs further.
A storage account can have multiple blob containers that you can store data in. So let's say this container here is a blob container. Doesn't matter what kind of blobs or items that are in here and what I place in it. I could have my little birdie as a blob item. I could have my PS4 controller, or even some scissors. They will all fit. It doesn't matter what they are or what size they are. Each of these blobs or items will have a unique address. So if, for example, I want to get the scissors, I can get them directly and quickly with no fuss. I know exactly where they are. So think of your blob container as a mixed bag of items that are all labeled in a sensible manner.
From the ground up, blob storage was designed to be versatile and suit a ton of scenarios. Images are often of very different sizes and formats, and blob storage makes storing and serving them to a browser straightforward. You can store any kind of files to provide distributed access, streaming video and audio directly, writing to log files as they grow at various rates, any kind of data store such as backup and restore, disaster recovery, and archiving of data. Azure Storage supports three types of blobs. Block blobs store text and binary data up to about 4.7 terabytes. Yeah, huge blobs. Block blobs are made up of blocks of data that can be managed individually. Append blobs are made up of blocks like block blobs, but are optimized for append operations. Append blobs work really well for scenarios such as logging data from virtual machines. Page blobs store random access files up to 8 terabytes in size. These are files where any part of the file could be accessed at any time. These page blobs could store a virtual hard drive, a VHD file, and serve as a disk for a virtual machine on Azure, for example. Blob storage come in three main pricing tiers. Hot for frequently accessed files. This tier has lower access times and higher access costs. The cool access tier has lower storage costs and higher access times compared to hot storage. This tier is intended for data that will remain in the cool tier for at least 30 days. And then the archive tier has the lowest cost and highest access time. More on archive storage later in this chapter. Up next, yep, you guessed it, more storage. In this hands-on lab, we're going to create a virtual network and we're going to connect it to other resources in Azure. We are back in the portal, and the first thing we want to do is create a virtual network. We go on the left here under virtual networks, and we're going to add a new virtual network. So click on add. We need to give the virtual network a name. So we're going to call this ACG VNet. I'm going to give it an address space, which is the range of IP addresses that can be assigned to the services on this virtual network. So this is a notation that you don't need to know right now, but you can copy it in if you want to create a virtual network as well for 256 addresses, meaning we can have 256 resources attached to this virtual network. We need to create a new resource group. We're going to call this VNet RG. Click OK. Give it a location, Australia Southeast, works for me. And then we need to give it a subnet. And this subnet is a range of IP addresses that are in a group. That's all you need to know. There you go. We got 16 addresses in our subnet. And then we just click create. Don't worry too much about all the details in this. These are standard properties that you need to enter to create a virtual network. But you can just copy them if you want to follow along. And now our VNet has been created. So if I click refresh, and there's our ACG VNet. I now need to add resources to this VNet. So let's create a virtual machine that is going to use this VNet. We're going to add a virtual machine. So this is now getting slightly more technical. Normally when you create a virtual machine, it will create a VNet for you if you don't specify one. But in this case, we're going to specify one. So we're going to choose our VNet RG. Our virtual machine name is going to be ACG VM. We're going to choose a Windows machine. And again, we need to give it a username and password, ACG admin, and a password to log into this machine. There we go. And then we click, instead of clicking review and create, we click next. And we can choose a disk type. We're not going to, we want to get to the networking tab. So in here, you can see that the virtual network has already been pre-selected. So that's the one we just created, ACG VNet. So this virtual machine is going to be created on the VNet that we just created. This means the IP address internally, so this is within Azure, from machine to machine inside Azure, not on the internet, will use one of the IP addresses that we have just created on this virtual network. We need to give it a subnet. We'll use the subnet we just created. And then we can give it a public IP address, and it's going to create a new IP address for us, which is fine. But we're going to leave the rest as default. The main thing to take away here is we've created a virtual network, a VNet. This virtual network has been selected in this dropdown up here. And we're going to use this virtual network for this virtual machine that we are creating. So we can review and create, and it'll now validate all of the properties that we have entered. And the validation is passed, so we just click create, and it will now create our virtual machine using the VNet that we have just created. And our deployment is now complete for our Azure virtual machine. We can go to the resource, and let's have a look at our virtual machine. We can then see here on the top right that the virtual network and subnet is the ACG VNet that we configured before. So we now have a virtual machine on that virtual network. You can also add many other resources in Azure to this virtual network as long as there are available address space, as long as they can get each their own unique IP address. A virtual network is what is behind everything on Azure. So every single thing on Azure is part of a virtual network somehow, so that the services can talk to each other and talk to the outside world. And then, as in any other lab, we now have to remove our resources so that we don't accrue any costs. So go to resource groups, and we're going to go into our network watcher RG, which is created with a virtual network. Delete that resource group. Just type it in here. Delete that. Resource group has been deleted. So we go into the second one here, VNet RG. Click on delete resource group, VNet RG, and delete that. And now our resource group has been deleted. And we have now again cleaned up everything that we created so we don't incur any costs. All right, onwards. Disk storage is pretty much what it sounds like. It's a disk that you can store data on. But of course, there is more to it. A managed disk, which is also what disk storage is referred to, is what you attach to your VMs. Managed is the keyword here. It means that Azure will look after the physical disk for you and guarantees its uptime and backup. You don't have to worry about size or performance either. This is all part of your agreement with Microsoft for using Azure. It also means you can easily upgrade the disk size and the disk type. Speaking of disk type, this is important when it comes to performance. And there are 4 main disk types that you can choose for your VM, one more expensive than the next. Let's start with HDD, which is your old school spinning hard drive. This is a low-cost storage option for having data that you can access infrequently. This is for scenarios like backup or for testing any scenarios you are developing. Next step up is a standard SSD or solid state drive. This is generally the norm for any production environment. Running a VM with a standard SSD gives you lower latency than a HDD, improved reliability, and better scalability. Then we get to premium SSD, and premium is always better, right? This is super fast, high performance storage for your critical workloads. Premium SSDs are recommended for database installations in particular, as the latency is very low. There are lots of large numbers to measure its performance, but all you need to know is that it's better than standard SSD. Finally, there is UltraDisk, which has unicorns flying out of it. Well, not quite, but it is the top tier of storage. This is for your most demanding, data-intensive workloads, delivering unprecedented and extremely scalable performance with sub-millisecond latency. Those were Microsoft's words, but they describe it. You can even have disks up to 64 terabytes in size. Huge disks! Microsoft recommends this tier for transaction-heavy workloads, complex analytical modeling, gaming, rendering, and low queue-depth databases. So that's disk storage, a flexible, managed solution for your VM and other services. What do you do with data you just have to archive and want to pay very little to store? Well, you use Azure Archive Storage, of course. For a number of reasons, including company policies, legislation, and recovery scenarios, storing large amount of archive data is often something that is required. The Azure Archive Storage service is here at your service. It is the lowest price storage tier within Azure, and you can store terabytes of data for just a few dollars a month. It isn't very fast, nor performs very well, but it doesn't have to either. It is low cost, durable, and encrypted, and perfectly suited for that data that used to be in a basement B in the old archive boxes in the corner. A really good reason to place archive data in the cloud, apart from low cost, is that it can free up your more valuable on-premises storage. By moving data to an archive storage, you can repurpose storage infrastructure for more important things. The archive data is secure, as it could be sensitive data such as financial records, medical data, or other personal information that is stored. As I mentioned earlier in this chapter, archive storage is a blob storage tier. This means any tooling used to access blob storage will also work for archive data, making it easier to manage and integrate into existing workflows. Next, a brief summary of storage. There are many advantages of using cloud computing, and of course those advantages also apply to storage accounts. Let's look how this works with file storage. Most companies will have file shares that are used to store all of the company's assets. Users will upload, delete, synchronize, and do what they need to do to work with the files. Nothing unusual about that. Having on-premises can have some issues though, such as disk space constraints. You only have a limited amount of storage. Backups needs to be configured and maintained. Security of data can be hard to maintain and requires specialists to enforce. Extending file sharing to other teams, organizations, and entities require more infrastructure to both supply and manage. All of these issues can be resolved though by using a file storage account on Azure due to the cloud benefits that include: you can share access across multiple machines and can seamlessly connect to your existing infrastructure. Fully managed, which means you don't have to worry about hardware or operating system. Azure takes care of it. File storage is super resilient and always available. Network issues or power outages will no longer take out your file storage, such as it can on your on-premises networks. Azure is always on, as it has redundancies built in. Some useful scenarios for using file storage on Azure are: if, for example, your on-premises file storage is running out of space, you can use Azure File Storage to supplement it. You can also completely replace the on-premises file storage solution. Azure comes with redundancy and backup features as standard. Or lift and shift, and this is kind of a buzzwordy way of saying that Microsoft would very much like you to move all your infrastructure to Azure. And because you can almost take your existing infrastructure and move it service by service, it is called lift and shift. The file storage solution is a good match for doing this with your existing file storage. So that's file storage on Azure. It's your friend. Let's move on to the kind of storage you hide in the basement. Storage is another foundation of Azure services. Along with compute and network, storage is part of pretty much every single Azure service or product. So while this chapter was short and succinct, the storage component of your fundamental Azure knowledge is important. You learned about 4 different types of storage in this chapter. Blob storage is your general kind of storage that can hold anything you'd like. It comes in 3 varieties: block, append, and page. Blobs are stored in containers, which are inside your storage account, and you can choose hot, cool, or archive pricing tiers. Disk storage is what you attach to your VMs. Like the other storage types on Azure, this is a managed storage service, so you don't have to worry about hardware and loss of power. The types of disks are HDD, old-fashioned spinning hard drives, SSD, premium SSD, and UltraDisk. They increase in speed and price while the latency go down. File storage is for mitigating some of the issues with having file storage on premises. Using Azure gives you easy sharing of files, always available and super resilient to outages and issues. Finally, archive storage is a very cheap way to store large amounts of data you don't need, well, frequently anyway, probably ever. So storage for Azure, done! Moving on to the next chapter. Choo-choo! In this hands-on lab, we're going to create a storage account and going to upload some data to it. We start again in the Azure portal, and to create a storage account, on the left under Storage Accounts, you click that and you click Add to add a new storage account. We have to choose again our subscription, free trial. We will create a new resource group. We're going to call this Storage ACGRG. Click OK. We need to give the storage account a name, and this has to be all lowercase and no funny characters. So we're going to call this Storage ACG Test. And the location, we'll keep that as Australia Southeast. The performance of standard or premium. Standard is less performance than premium, depending on how much you need, how fast it needs to be. Just leave the rest as default for this lab. You review and create this storage account, which means we have accepting the default for all the other values. The validation has passed, and we click on Create to set up our storage account. And our storage account has been deployed, it has been created. So let's go to the resource and have a look. So here's the overview of our Storage ACG Test storage account. We can see some of the properties that we defined before, but we can also see the services here in the middle, and that's what we're going to focus on in this lab. We have containers, file shares, tables, and queues. We're going to click on containers, and this is blob storage that we talked about in the lecture as well. It says we don't have any containers yet, so we need to create a container, give it a name. We're going to call this ACG container, and private is fine. We can choose different access levels if you want it, but we're just going to click OK for the default. And that will create a storage container for us real quick. And then we go into the storage container. Remember in the lecture on the slides for this particular types of storage, the blob storage, there's a storage account with a container inside it with a blob storage inside of that. All right, let's upload a file to our blob storage here. And we go in onto my file system here. I'm going to choose this beautiful photo. And it's uploaded the photo onto the storage account. Close that. And we can now see we have a file inside of our container, which is inside of our storage account. We created this container as a private container. If I change the access level now, and I change it to read-only access for blobs, I can now access this photo on the internet. So let's try that. So if I click on the photo, you can see there's a URL here. So this is a web address, an internet address directly to that photo. So if I click on copy here, I open a new tab, paste in the address, and then go directly to this. You can see, whoa, there it is. So I've now uploaded this photo to blob storage, which is inside a container, which is inside a storage account, and it has a direct link on the internet to this photo because I have chosen to change the public access rights to read only for blobs. So here's the photo on that blob container. So let's close that and let's go back, and as always, let's clean up our resources by going into resource groups, going into our storage ACGRG, and we're going to delete this resource group and everything inside of it. Type in the name of it and click delete. And we're now going to remove the storage account and the container and the photo that I just uploaded before. And we have now deleted our resource group, and we have removed all of the resources that we just created for this lab. Now that you know what the aim of a database is in general, let's focus on one of the most ambitious instances of one, Cosmos DB. And let's start with some of the really cool features that Cosmos provides out of the box. One of the key parts of Cosmos is its ability to be global from the start, and with a click of a button. So why is this a big deal, you might ask? Well, having data near your users is a key in providing the best experience for your users. Databases of old were notoriously difficult to set up across multiple locations, and keeping them in sync. With Cosmos DB, the entire headache of global distribution of your data is taken care of by Azure. For example, if you have the data in the region of US East, West Europe and South Africa, and want to expand to Australia, all you have to do is click on that region in the Azure portal to enable it. Ta-da! Done. Azure then takes care of moving the data and keeping it in sync. Pretty darn neat, if you ask me. Latency is the time it takes for data to travel. The higher the latency, the longer it takes for the data to reach your user, and we know that internet users are less patient than a toddler waiting for a lollipop. Cosmos DB promises single-digit millisecond latency anywhere in the world. That is less time than it takes for you to blink. Try it. Nope, Cosmos is still faster. You can scale Cosmos DB to infinity and beyond. Well, when demand goes up, at least you can set Cosmos to automatically scale with demand for each region and instance. More resources are added, and there is no known limit to how many users can be supported. Your users are all met with open arms. And the best part is that you still only pay for what you use. As your application usage increases, you can dial Cosmos up to follow along. Cosmos DB also supports a large range of ways to work with it. If you're a developer, you can choose from a bunch of built-in ways to connect your application to Cosmos, such as software development kits, or SDKs, application programming interfaces, APIs, and more. You can use different languages, such as C#, Java, and Node.js. There is also a large range of platforms, such as SQL, MongoDB, and Cassandra, to make it as seamless as possible to use. Now, don't worry if you don't quite know any of the languages or platforms, just know that there are many possibilities. One of the pitfalls with Cosmos DB is that it can get really expensive. Now, you definitely get what you pay for though, but costs can run up as Cosmos scales up. It is something to keep an eye on. Azure does have many great tools to help you stay on top of costs as well, but those are outside the scope of this course. Next, more databases! Microsoft SQL Database was launched in 1989 and has been one of the most stable Microsoft products since. It's no surprise then that there is a managed Azure SQL service as well. Azure SQL is in effect a database as a service. As with other fully managed services, Azure will take care of your hardware and infrastructure level needs. That includes servers, storage, network, and everything else infrastructure related. Azure SQL just sits on top of this and provides you with the business logic and functions you need. Think of Azure SQL as a fully fledged database solution where Azure is managing all the parts that don't have anything directly to do with managing the data in the database. One of the main use cases that Microsoft highlights for Azure SQL is that you can migrate your on-premises SQL Server instances directly to Azure and get all the benefits of managed instances. No changes are needed to your on-premises databases, and it is all frictionless. This can bring about significant cost saving for businesses and bring down the total cost of ownerships, also known as TCO. Azure SQL takes advantage of being on a cloud platform by integrating machine learning aspects too. Database performance and optimization suggestions are provided based on your usage patterns and other metrics. Machine learning will also warn of any degradation and detect if there are bad things happening to your database that affects performance. There's a whole lecture on machine learning in this course for you to learn more too. Of course, because it's a cloud service, you get excellent scalability and high availability. Azure SQL supports up to 100 terabytes in size and can restore huge databases in just a matter of minutes, should it be necessary. Security is also part of the appeal of managed services. With Azure SQL, you benefit from the massive team behind Azure and their efforts in securing the platform. You don't have to worry about data security on the infrastructure level, as Azure is on top of that. Azure SQL is a service for real grown-up kind of applications with large amounts of data and possibly some legacy features that have been supported on Microsoft SQL Server for a long time. Next up, migration. In this lecture, we cover the community-based cousin of Azure SQL, Azure Database for MySQL. Now, there are many varieties and types of databases. We look at Azure SQL in this chapter 2, and that is one kind, where Azure SQL is a Microsoft product. MySQL is built and maintained by the community. It's an open source project where anyone can contribute to new features and maintenance, and it is relational just like Azure SQL. Relational meaning the data is related to itself and other pieces of it through defined connections in the database. For example, the table of customers is related to the orders table, so you know which customer made which order. There are millions of MySQL databases in use, and a lot of the public internet is backed by MySQL. It is a mature and proven architecture. I have mentioned this many times in this course, and I will continue to do so, but the advantage of using Azure services is that many of them are platform as a service offerings. This means they are completely managed by Microsoft, and you don't have to maintain hardware, servers, or security for them. Azure Database for MySQL is the same. In particular, Microsoft highlights the following advantages of using the managed version of MySQL. You can focus on development of your core business processes rather than managing infrastructure with the managed version of MySQL. Use any language and framework of your choice. One of the most popular content management systems used today is WordPress, which uses MySQL as a database and PHP as a programming language. You can use WordPress on Azure with Azure Database for MySQL. Get high availability and scale your application super fast to handle many more users, because cloud. Use all of the security features of Azure, such as advanced threat protection, monitoring, and identity management. You can find more information about those in other parts of this course too. Cloud PaaS capabilities such as automatic database patching, automated backups, and built-in monitoring, all at no extra cost. Some of the user cases Azure highlights for MySQL are pretty much the same as for other relational database types. There are web applications that uses machine learning and analytics, e-commerce implementations so you can go shopping, mobile applications that can scale to millions of devices, digital marketing experiences that have very large spikes in traffic, finance management applications that store and manage highly sensitive data, and of course, gaming applications that manage large spikes in data and traffic but must have low latency. Nothing worse than playing a car racing game on a satellite connection. Azure Database for MySQL is another great option in the managed database selection of services on Azure. Because managed database instances is what Azure does, another offering is Azure Database for PostgreSQL. Often just called Postgres, this weirdly named database is an open source relational database offering similar to MySQL, also covered in this chapter. The name is because the first version was based on a database called Ingress, and this new version came post that, Postgres. It then became PostgreSQL to reflect support of SQL, which is the language used to query the data in the database. It's free and has been around since 1996, and it has a huge user base as well. Among other things, it's the default database for macOS. Some of the features that make developers and businesses use PostgreSQL includes integration with lots of additional features through extensions such as JSONB, a binary version of the popular JSON data format, geospatial capabilities, rich indexing, integration with Visual Studio Code, and much, much more. You can also use your programming language of choice, such as Ruby on Rails or Python. Horizontal scaling with hyperscale. This allows very high performant distributed data use across many PostgreSQL instances. You can scale easily to hundreds of nodes with no application rewrites, like magic. Performance recommendations based on how you use the data and the database. There are features to monitor and detect disruptive events that can hamper performance, which you can then action. Fully managed cloud capabilities such as automatic database patching, automatic backups, and built-in monitoring, all at no extra cost. Some of the best use cases of industries that use Postgres are the financial industry because it's ideal for online transaction processing. It can also be integrated nicely with mathematical software such as MATLAB and R. Governments use Postgres for geometric data, also known as GIS or GIS. There's a powerful GIS extension called PostGIS, which provides hundreds of functions to process geometric data in various formats. In industrial manufacturing, reliability is everything. If a production site is down due to a failure, it can easily cost millions. PostgreSQL has been a great choice because it can be configured for automatic failover, full redundancy, and almost zero downtime upgrades, all crucial to the manufacturing industry. So PostgreSQL is another offering on Azure for database management that makes sense in a lot of cases. Alrighty, on to the next lecture. In the previous lecture, we talked about migrating databases to Azure, in particular SQL Server. How do you do it though? With database migration services, of course. Azure has a dedicated tool to transfer your database from on-premises to the cloud. After all, they want you to be on Azure, so why not make it as easy as possible? The appeal is that a single tool can move your existing SQL Server in one fell swoop. No other steps are required. There's comprehensive documentation for helping you choose the right settings and providing step-by-step guidance for completing the migration of your data. There's even very detailed guides on migrating from non-Microsoft databases to Azure SQL, which is a managed PaaS service, or Azure SQL Server, which is a non-managed IaaS service. So let me show you how valuable Azure DMS is. Let's say your company, Rainbow Dolphins, have everything on premises. You have an online shop and your current database is a Microsoft SQL instance that runs in your server cupboard. Yeah, you know it does. With database migration services, you can simply move the SQL Server from your on-premises to a managed Azure SQL instance in the cloud. And say you had a MySQL database in your server cupboard that you wanted to get onto Azure, DMS can help you there too. In the second scenario, you might have to do a little bit more of the work manually, but Azure Database Migration Services will have steps for you to follow all the way. It's a very smooth and simple way to get your data on Azure. All right, that's it. Next up, a database of databases. Managing data is a key area for any modern business. We're collecting vast amount of data from any number of collection points, and all that data is stored somewhere. To make sense of it, it's often placed in a database. And of course, Azure has a database service that will suit your business requirements. In this chapter, we'll go through some of the key Azure database offerings that you need to be aware of and somewhat familiar with for the exam. They include the following: Cosmos DB, which is a globally scaled and fully managed database service. It's extremely powerful in global scenarios and have very fast reads and writes. Azure SQL is a managed take on one of Microsoft's oldest database products. It is tying the gap between new and old. We'll look at the world's most popular community-based database, MySQL, and how that works with Azure. And then there's the second open source database in this chapter, PostgreSQL, which has a bunch of unique features, and it also runs on Azure. And finally, if you want to migrate multiple database sources to Azure, you can use a tool like Database Migration Services. These are all examples of some form of data management in the Azure cloud. But before we go into each though, here's me, again, with a brief explanation of how databases work.
Here's a pile of documents. Well, books. But these books are all in a big pile, which isn't very helpful if you want to find a specific book or store them for later use. So say this environmentally friendly bag is my file system on a computer. I can put all these books in it, and they're now stored on my computer, well, in this bag. And it wasn't even big enough. You can see my file system ran out of space. Certainly better than having documents everywhere as they were before, right? However, I need to know exactly where the book or document is, well, to find it, right? I need to actually go and look at it to find the exact book I want, right? So let's say I use a database instead. Here's my database. I get even more benefits. So when I add documents, the database management system automatically now keeps track of all my documents, and they've sorted them for me as well. And it went really quick. Right, as I added them, got sorted. I can now ask the database to give me all the books starting with A, or give me all the blue books, or give me all the books of more than 200 pages, or whatever it is that your search criteria is. So you use a database not only because it's a great way to store files and data, but because it is so incredibly powerful at getting the data out in exactly the format you want. So keep that in mind for the rest of this chapter.
As with any technology service and IT application, you don't want the wrong people using it. Controlling who accesses which parts of your infrastructure exactly is critical. In this chapter, we go through the fundamentals of authenticating and authorizing users in Azure. Don't worry, Azure will do most of the heavy lifting for you, but there are some areas to understand. In particular, you'll learn about what is identity in an Azure context and how are you as a user identified on the platform. You learn about identity services, which is what takes care of making sure the right users and processes are let in. Also, what is the difference between authentication and authorization? Azure Active Directory is the core identity service to give access and control this access to users and processes. You'll learn about the various core components of Azure Active Directory. As an added security feature that is becoming a standard, we go through multi-factor authentication, which is using multiple things about you to authenticate you. Not a huge chapter once more, but that doesn't mean it's not important. Let me introduce you to my friend, identity. Databases are catalogs of optimized, sorted, and streamlined data for you to use in your business. They're great at storing files and data, but also incredibly powerful at getting the data out in exactly the format you want. In this chapter, you learned about several database-related services in Azure. Cosmos DB is a globally distributed database offering that is super fast and super easy to manage. You can scale it to any size and performance you want, but be aware that it can be costly. Azure SQL is a fully managed database using the tried and tested Microsoft SQL technology. You don't have to worry about hardware or servers, but can jump straight into using SQL. It's also compatible with your on-premises SQL Server instances. Azure Database for MySQL is a managed approach to using the most popular community-driven database. It is a relational database that is used in millions of applications and is both mature and stable. PostgreSQL has a strange name, but this is a very popular choice of relational database. You get enterprise-level features like horizontal scaling and lots of extensions as well. Azure offers a managed approach for using it, which gives you all the cloud goodness for free. Finally, if you want to move your on-premises database to Azure, you'd most likely use Database Migration Services. This service makes it a smooth experience to migrate almost any kind of database to Azure SQL and SQL Server. You get guides, step-by-step instructions, comprehensive documentation, and much more. So thank you for staying with me this far, but on to the next chapter. Whenever you use an online service that has any aspect of personalization, chances are that you have provided personal credential to that service. You have at least a username and password. In this lecture, I'll give you an introduction to how Azure will both authenticate and authorize you, as well as what access management is in general. And we start with me, with a picture of me.
What is the difference between authentication and authorization? There's an important distinction and it can be hard to remember the difference sometimes. Say I would really like some of these delicious chips, tasty snacks, or maybe this zesty drink. We could call them the Azure service for the sugary inclined. But how do I get access to all this goodness? Let's start with authentication. Authentication is confirming that I am me. This can be done in lots of ways, but the most common is the username and password method. You're probably familiar with that. Or on your latest smartphone, it could be your face. Ooh. If the service can confirm the details I provide are correct, obviously this is me, I am authenticated. I am indeed me. But just because I am me doesn't mean that I can dive into these bowls of deliciousness. The application might know that I ate all the chips last time, or that I'm a diabetic and shouldn't have any of it at all. I haven't been authorized to eat them. Bugger! But the Azure service for the sugary inclined has my profile. I just authenticate it with it and will then authorize me to access none, one of them, or more. First you get authenticated, then authorized.
Let's iterate what authentication and authorization is. Authentication is confirming you are you. It is making sure you are the person or process you say you are. It is confirming the identity. If you can't be authenticated when needed, then you don't get let in. It's a first test. Authorization only comes after authentication. If you aren't authenticated, there will never be a question of authorization. Authorization takes your identity and asks, is this identity allowed access? If not, then authorization fails. Authorization is the granular part of identity services. I hope that makes sense, because you'll need to know the difference between authentication and authorization. In general, access management is a critical part of any cloud infrastructure for obvious reasons. You don't want to let just anyone have access to your business applications and processes. Azure has various ways to provide access management depending on your scenario. Next up, let's go through the main one. In this lab, we're going to set up an instance of Cosmos DB and see how that works. I'm back in the portal, and to create an instance of Azure Cosmos DB, on the left here it says Azure Cosmos DB. So we click on that, and you click on Add to add a new instance of Azure Cosmos DB. And remember, Cosmos DB is a really good example of why cloud scale matters, why we put things in the cloud. It's a database that scales globally with basically a click of a button, as we'll see in just a second. So let's create a Cosmos DB account. We're going to create a new resource group. We're going to call this Cosmos DB RG because that's what we're doing. And then we need an account name for the Cosmos DB database. So we're going to call this ACG Cosmos. And then we'll leave the rest as default. Actually, I'll just change the location to Australia Southeast, because why not? And then we review and create this Azure Cosmos DB. And the validation has succeeded for our Cosmos DB, so now we can create it. And now our Azure Cosmos DB has been created. So let's go to the resource and have a look. And here's the overview of the Cosmos DB. You can see there is also an internet address, the URI, acgcosmos.documents.azure.com, and that is the address used to access the data in the Cosmos DB if you were accessing it from another application outside of Azure or outside of your account. The interesting thing we'll look at in this lab is go to replicate data globally, and you get a map of the world where you can enable more data centers. So right now you can see on the world map on the bottom right, Australia Southeast has been ticked. So currently Australia Southeast is the only region that Azure Cosmos DB is deployed to. But I can go and click and see if I had a lot of customers in the Middle East, I could click on UAE North, and that would be added to my Cosmos DB account as a destination, which means that the data would be delivered from UAE as well. And let's say I wanted to add the East US data center region as well. I've now added 2 more regions. I click Save, and the configuration of those regions is going to happen, and they're being updated. So now we have 3 regions that are all part of our Azure Cosmos DB account. This means that the data is replicated automatically across these 3 regions. And this is the power of the cloud computing infrastructure approach, is that you can have services like this that with a click of a button, it is suddenly deployed to other parts of the world to make a better service for your customers if they are in that part of the world in this case. Azure Cosmos DB is extremely powerful. It is one of the key services on Azure if you want to have a global infrastructure, but that is as much as we're going to go through now in this lab. Let's just remember though, we need to clean up. So let's go back into resource groups, into our Cosmos DB RG, and we're going to delete this resource group, Cosmos DB RG, so that we don't get any costs, because Cosmos DB can incur a fair amount of costs if you have it in multiple locations in the world. There's a lot of infrastructure that goes with it, so that needs to be paid for somehow. So it's a good idea to remove it or stop it if you are not using it. So let's remove it now. And then the resource group has been deleted, and we are now free of costs for using Cosmos DB. Multi-factor authentication, or MFA, is a critical part of modern online security for your applications. If you aren't familiar with multi-factor authentication, it is when you need at least 2 ways to identify yourself to log in. The integral security aspect of using MFA is the layered approach to authentication. Using more than one form of authentication means that if one is compromised by attackers, they are still not getting in. Bad attackers. Generally, MFA consists of 2 or more of the following authentication methods. Something you know, which is almost always a username and password. Something you have, such as an app on your phone or a key fob. Something you are, meaning a fingerprint or retina scan, for example. Biometrics, in other words. For example, let's say you want to log in to your favorite gingerbread cookie recipe website, and you are asked to enter your username and password. Getting this correct is one factor of authentication, so to make sure your credentials haven't been compromised, a code is sent to your phone, which you receive and enter into the website. The system uses something you know, your username and password, and something you have, your phone, to make sure you can get access to gingerbread heaven. MFA is recommended as a default, although there might be specific scenarios that you won't want to enable it as an Azure admin. MFA is enabled through Azure Active Directory and is built into Azure as a first-class citizen from the start. So that was it for this chapter. Next, a little quick summary for the exam. Authentication and authorizations are key elements of the Azure ecosystem. So let's summarize for the exam. Azure Active Directory is a key part of identity services, and you can't use Azure without it. Active Directory, AD, is not the same as Azure Active Directory, AAD. The former is the identity management solution for your on-premises implementation. The latter is an Azure service for identity management. AAD is the first service that is created on any new Azure account. A tenant is a special instance of AAD. It is the first AAD instance that gets created when a new Azure account is set up. The tenant represents your organization and holds the users for it, and a user belongs to a single tenant. While users can be guests to other AAD instances, they belong to only one. A subscription is a billing entity. All Azure services belong to a subscription, which is what issues an invoice every month. If a subscription stops, such as being unpaid, all the services within stop too. Using AAD can help with your hybrid cloud setup and manage users across Azure and your on-premises setup. And multi-factor authentication is an extra layer of security using something you know, something you have, and something you are. Now, doesn't it feel good to smash through the chapters like this? So let's do the next one. In this lab, we're going to look at Azure Active Directory. We're going to create a new user and see how we can use this user for accessing other resources. We're back in the Azure portal, and on the left, we have Azure Active Directory, which I'll click, and that opens up the current Azure Active Directory. Remember from the lectures that Active Directory is the first resource that gets created with your Azure account. You cannot have an Azure account without an Azure Active Directory. This is where your users live. So here is an overview of what is currently in the default directory. Let's go into users, and that'll show the users that are currently in this tenant being the first Azure Active Directory. And there's me, Lars Klint. So let's add a new user to this account or to this Active Directory. Let's call this ACG Unicorn. That's going to be the username and also their email address at AZ-900 by azgoutlook.onmicrosoft.com. It's a bit of a mouthful, but that is the address they're going to get. And we're going to call this mascot, because who wouldn't want a unicorn as a mascot? We can give it a first name and last name. And this will be Sam Kroonenberg. That is probably the best unicorn I know. We'll auto-generate a password, and then we'll just click create. And we've now successfully created a second user on this Azure Active Directory. If we go into this user, we can now see the details that I have filled out. And we could then use this new user to assign roles. We could assign access to other parts of our Azure account, such as a Cosmos DB, a virtual machine, storage, or anything else on Azure we could grant access to. So Azure Active Directory is a very important part of Azure. It is a part that you must have and always will have on your Azure account, and you use it to manage your users and resources and access to them. Managing users and permissions in Azure is not trivial. It's a large task that requires expert knowledge and skills. Don't worry though, I won't ask you to become an expert during this course, but you do need to know about Azure Active Directory, which is the main tool to manage users and permissions. Before we delve into the Azure side of things, let me start with Active Directory. While the name is very similar, without the word Azure, it is a quite different product. First of all, Active Directory was designed for a traditional office with computers, printers, and physical access. It was still for managing users, but users that were on premises. Active Directory was not designed for web and its distinct architecture. Web-based services and access management for those was just not a thing in 2000 when AD was conceived. While authentication as a concept hasn't changed, the way to do it and the services to provide it are very different in Active Directory than in Azure. So let's explore the main components of what makes up Azure Active Directory, which usually is merely referred to as AAD. And just a disclaimer before we get into the meatiness of AAD. Microsoft, as I said before, has a product called Active Directory, which companies host themselves. While both this and Azure Active Directory focus on managing users, they are not the same product. They're very different products. it is unlikely that you can transfer knowledge from one to the other. So with that in mind, Azure Active Directory or AAD is a service like everything else on Azure. However, AAD is a bit different because you can't have an Azure account without an AAD service. Every Azure account has to have a first user and owner, and that user needs to be in an Azure Active Directory instance. So the first thing you get when you create a new Azure account is an AAD service or instance. Let's start with the concept of a tenant. This is a representation of your organization in Azure. A tenant is a dedicated instance of Azure Active Directory, which is the first AAD instance that is created when a user signs up for Azure or another Microsoft Cloud service. It is the instance of AAD I mentioned just before, the one that is created as the first thing in a new Azure account. Each Azure AD tenant is distinct and separate from other Azure AD tenants. A user belongs to a tenant and only one tenant. All users in Azure are part of an AAD instance, but can also be guests in others. This means that while a user belongs to a single tenant, they can be guests of others. And then there are subscriptions. These are billing entities that will get an invoice each month for the Azure resources that have been used and are associated with that subscription. You can use subscriptions to separate who pays for what, as you can have multiple subscriptions within a single tenant. And if you don't pay your Azure bill for a subscription, all the resources and services linked to it will stop working. Pay your bills. AAD has a few tricks up its sleeve though, especially when it comes to creating a hybrid cloud architecture, which is a reality for many organizations. In a hybrid cloud architecture, you have some services on-premises and some are hosted in Azure. When you want to set up a hybrid cloud infrastructure, AAD can help manage your users both in the cloud on Azure and on your premises. There are several services that can let Azure do more or less of the management, but it becomes much easier than you'd think. I won't go into details in this course about managing a hybrid scenario, but be aware that AAD is a significant part of such a hybrid setup. Let's recap for the exam. Azure Active Directory is the main tool to manage users and permissions on Azure. First of all, Active Directory, the tool for on-premises management of users, computers, printers, and more, is not the same as Azure Active Directory. Thank you, Microsoft, for that naming. It is unlikely you can transfer knowledge from AD to Azure AD. It is a different skill set. You can't have an Azure account without an Azure AD service. It is the first service that is created on a new Azure account. A tenant is a dedicated instance of Azure AD and represents your organization. It's also the first instance of Azure AD created on the account. A user belongs to a single tenant, but can be a guest on other tenants as well. A subscription is a billing entity, and if the subscription is restricted, so are all the resources within it, and all resources belong to a single subscription. Azure AD can help you manage users in a hybrid cloud setup as well. Next, let's dive into authentication a bit more. As you've probably realized by now, Azure has a ton of products, features, and services. Of course, we can't go through all of them in this course. I mean, that would be like 6,000 hours of your life you'd never get back. But we can explore. We can explore some of the many cool things you can do with Azure. And these include the Internet of Things, often called IoT, is about as broad a term as you can get. I mean, things. What does that even mean? Well, you'll learn the concept of IoT and some of the products and services that Azure offer in this space. The idea of big data is to manage, manipulate, and make use of very, very large data sets. We'll go through some of the Azure services you can use to work with big data and get value out of it all. Artificial intelligence and machine learning in general is taking over lots of processes and business decisions. As we learn how machines can make decisions, we need the right tools. We'll have a look at how this works in Azure. We cover a technology and architecture approach very close to the heart of all of A Cloud Guru, serverless. As this approach to building cloud applications gains traction, the tools just get better and better, and we will look at the most popular ones. Finally, DevOps is a modern way to connect application development with running a smooth production environment. We'll cover 2 Azure tools to help you do just this. This chapter is an overview of solutions you can use Azure to build and problems to solve. Hold on, let's get into it. Modern business system processes very often means collecting data. Lots of data, like enormous amounts of data. So let's talk about big data. Data is everywhere we look. How many cars are passing by, what the temperature is, how many newspapers are sold, how many visitors to a museum, and on and on. That data can be incredibly valuable for businesses, and they collect tons of it. Now, collection of data is not that hard. Store everything that passes through your system, and voila, you have data. However, getting any value from it at all is a very different matter. That's where the idea of big data comes in. How big is big though? Well, it's big, like really big. So big that most common software applications wouldn't be able to collect, store, or process it. Think data from millions of devices in an Internet of Things scenario, for example. Big data keeps changing though as we can process more and more data. The definition of what is big data moves as well. So back to value from all of this data. Businesses want to get value from big data to provide better service, better products, and ultimately be more competitive and profitable. Azure, of course, has tools and services to help with this. Azure Data Lake Analytics is a great visual name. You have a massive body of data, a lake, that you can perform analytical procedures on. The main thing to understand when processing enormous data sets is that you need parallel processing of that data. This is 2 or more computers, or CPUs, that process the same dataset at the same time. They do it in parallel. With Azure Data Lake Analytics, you can do this without having to manage servers, virtual machines, or clusters of computers. You can jump straight into processing the huge dataset with thousands of parallel processes. Another similar offering is Azure HD Insight. Yeah, I know, the logo totally rocks. I mean, who doesn't like a yellow elephant? Now, this service provides a very similar service to Azure Data Lake Analytics, but uses all open source frameworks. Open source framework is another way of saying software systems that are free to use, and for which the community of its users help update and maintain it. Azure and Microsoft in general support a lot of open source projects, and this flows into products on Azure as well. HD Insights include products such as Apache Hadoop, which allows many computers to work together to solve problems which involves massive amounts of data. Apache Spark, which is an interface to allow parallel programming between clusters of computers. And Apache Kafka, which allows processing of real-time data feeds. Azure Databricks. Yes, I'll admit I also thought it was some huge beast of a computer to hold bricks of data. But no, it is a cloud service on Azure. Databricks is based on Apache Spark, which is an open source distributed cluster computing framework. Got that? Yeah, it means that Apache Spark can run on many computers at the same time and also process the same set of data on multiple computers at the same time. Neat. The advantage of using Azure Databricks is, of course, that you don't need to buy lots of computers nor maintain them. Azure provides the computing power and, on top, also offers a lot of integration points with all the other storage services on Azure, such as storage, analytics, and even data lake storage and Hadoop storage. You use data from all these data sources to find insights and analyze the data in Apache Spark, or Azure Databricks as it is called on Azure. The last service you need to know about for the exam is Azure Synapse Analytics. This is the data warehouse solution for Azure. In fact, it used to be called Azure SQL Data Warehouse. A data warehouse is a system used for reporting and data analysis and is considered a core component of most data-driven business decisions. The strength of Synapse Analytics is that it is in the cloud. It is limitless in storage and analysis capabilities, or at least, only limited by your wallet scope and the size of Azure data centers. Azure provides the Synapse SQL language, which you can use to cut, dissect, split, combine, and in any way mash up the data in any way you need. So what do you get out of all this data and work though that all these big data services do? Analytics of business data is not a new concept. However, the speed and efficiency which you get from big data on Azure is the real value. You can find trends and insights that you can act on straight away. And this leads to 3 main outcomes. Cost reduction. Big data technologies such as cloud-based analytics bring significant cost advantages when it comes to storing large amounts of data. Faster, better decision making with the speed of in-memory analytics combined with the ability to analyze new sources of data, businesses are able to analyze information immediately. And of course, new products and services. With the ability to gauge customer needs and satisfaction through analytics, comes the power to give customers what they want. This means companies can create new products to meet customers' needs much more efficiently. Up next, the evil robot overlords are taking over. Well, sort of. We'll start with one of the solutions in Azure that is becoming more and more prominent. A bunch of seemingly random devices connected to the internet to perform a larger task. And to explain the Internet of Things, let's cross to my identical twin.
Internet of Things. It isn't the greatest description ever conceived for a technology, but as I shall demonstrate, pretty accurate. I have here a line of cars. They're probably going to work and are stuck in traffic. They're stuck because up here at the front, there's been a crash. Johnny was texting Davo about this new cat picture on Reddit, and he hit the back of Carmela's car. Now there are multiple cameras sending images of the traffic. There's one here. And this imagery is sent to a cloud server. Each driver stuck in traffic, all of these, has a smartphone that is tracking their movement. Now this tracking data is also sent to a cloud server up there. All of these things form a network, an Internet of Things. Even though they can be all different devices, work in different ways, they are all connected to the internet. And more importantly, they're all sending data without any human intervention at all, and that's important. Now this data from the traffic cameras, from the smartphones, and more can then be used to inform about traffic congestions and travel times. This could lead to less congestion, less pollution, and better social efficiency. IoT is pretty darn cool.
To recap, the Internet of Things is a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are provided with unique identifiers and the ability to transfer data over a network without requiring human-to-human or human-to-computer interaction. Now, in other words, pretty much anything you can imagine as long as human interaction isn't needed for the data to be collected and sent. So let's look at which IoT services Azure have to help you out. There are two main ones we will cover. The first one is Azure IoT Hub. As you can deduct from the name, it is a hub to collate data feeds from all your things. It is what is called a backend, meaning the system that receives the data and manages it. It can receive data from millions and, according to Microsoft, even billions of devices. This is the power of IoT on Azure as well. Because these devices are meant to be autonomous and do their tasks without any human interaction, you could have a lot of them, billions even. So imagine a water network for a big city. The water comes from far, far away, and having it running smoothly is critical to ensure people in the city can open the tap and get fresh water. This makes the water network critical. There will be thousands of valves, pumps, gates, locks, and much, much more. And if any of these things fail, it could be disastrous for the water supply to the city. If every single thing was connected to the internet, then if any of them failed, you could see it instantly. It would create a much more stable and, over time, much more cost-effective network. You wouldn't have to spend time and money checking the network constantly in the field. IoT Hub on Azure will ensure that the entire IT solution is managed, secured, and that new devices can be deployed with ease. It is a Platform as a Service offering, or PaaS, from Azure. You get managed infrastructure, scaled resources, and device authentication. The second Azure service for IoT we'll look at is IoT Central. This is the Software as a Service, or SaaS, offering for IoT on Azure. IoT Central helps simplify the setup of your IoT solution and can be a really fast way to get your IoT solution running. You don't have to write any code to connect all of your things. IoT Central receives the feeds from your devices and provides you with dashboards, metrics, and rules to manage it all. There are hundreds of ways to connect the IoT system and data to your other business systems, all through pre-made connections in Azure. That gives you two ways to start an IoT project. Use IoT Hub for solutions where you want more control of the whole process and how you collect and manage the data. IoT Hub is a PaaS solution and creates a secure link for your data connections to the devices and make provisioning, that is getting them on the network and system, a lot easier to do for millions of devices. IoT Central is a SaaS solution that provides all the dashboards and infrastructure you need to create an IoT solution without any cloud nor IoT knowledge. It's a tool with many ready-made components for you to set up. Next, we look at how to manage very large amounts of data, possibly collected from IoT devices. Could be. Chances are that you've heard stories, fictional and non-fictional, about artificial intelligence. Of course, Azure has that offering too. Otherwise, I probably wouldn't include it in the course either. Anyway, AI is the capability of machines to imitate intelligent human behavior. Through AI, machines can analyze images, comprehend speech, interact in natural ways, and make predictions using data. So that's Microsoft's definition. In other words, we are teaching machines to make decisions based on what they learn. While some people want you to think of evil robot overlords, when you hear artificial intelligence or AI, it is a lot more benign and much less destructive. On the Azure platform, AI is most often called machine learning. AI is a subcategory of machine learning, although they are often placed together in the same bucket. Microsoft focuses on three main parts to how machine learning can be used on their cloud platform. The task of creating models for teaching your AI application is the essence of machine learning. A model is the way that you define what you want your machine learning implementation to learn. You give it a model, which is a set of rules, and the application then starts playing this model over and over again with the data you have provided. Over time, usually very fast, the model will find patterns in the data that follow the rules you have provided. Knowledge mining is when you ask Azure Search, a service from Azure, to find insights that are present in your data. This could be relationships between files, data based on geography, images with the same person in them, and much more. Ready-made built-in apps on Azure, such as cognitive services for recognizing speech and language, or bot services to create an automated process to answer questions in an interactive way. Bots are what you may have seen on websites as assistants ready to answer your questions, or something like that. AI as a service on Azure comes in a few different forms. They're all part of Azure Cognitive Services, which is a collection of tools to use in your own applications. The Vision service, which provides information about visual content found in images and videos. It will identify visual objects, people, and concepts, as well as caption the media for you too. The Decision service can make informed decisions based on data available to an app. This could include identifying potential offensive language, get notified of anomalies in your IoT network, or leveraging data analytics from your business. The Speech service takes any spoken audio stream and then convert it into text as a transcript. The service can also identify unique voices and even verify a speaker based on the speech. The main tool for using machine learning on Azure is the Machine Learning Studio. This is a visual tool that can help you manage all of your machine learning needs. It supports all the various programming languages, datasets, models, projects, and services that are available on Azure for machine learning. It has pre-made modules that you can just plug into your project and use straight away. Some of the use cases for Azure Machine Learning Studio could be a Twitter sentiment analysis of all your followers, grouping specific types of flowers in photos, or recommending movies for users based on data about them. Just as important as the Machine Learning Studio is, so is the actual Azure Machine Learning Service. This is the end-to-end service for using machine learning pretty much everywhere on Azure. It's a service that expands all of Azure and helps you use machine learning in more and better ways. It's a range of tools that helps you build machine learning into your products and Azure processes, and you get automated machine learning, which means Azure will pick up trends and processes automatically for you and create machine learning models that you can use. So AI is about better products and better customer service, much more than taking over the world. Next up, the world without virtual machines. All right, let's have some fun with using Azure AI. I'm at the aidemos.microsoft.com website. This is the hands-on with AI collection of sample AI applications that Microsoft has created to sort of showcase how artificial intelligence works. I'm going to scroll down here and I'm going to use the face and emotion recognition. So click on try it out. I'm going to add two photos. One is my profile picture. And then I'm going to add photo number 2, which first off is a silly photo of me. You may recognize it from other places in this course if you pay attention. And then what happens is that the AI application here, the face and emotion recognition application, uses the Face API from Microsoft to see if it is the same person. And it's saying it's not. 32% match means they're not the same person. It also tells me that the age is 34 in one photo and 50 in the other, and both have the emotion of happiness, and I am wearing glasses, which is correct. And then it says facial hair, yes, which is incorrect. So interesting. So we can try again. We can add another photo of the crazy Dr. Clint. And let's try that again with the silly photo, considering they're both silly. And we'll see what that brings about. And there's more match now, and they both happiness. I'm not sure about the happiness on the left. We could probably conclude from this that the AI model, the face API that Microsoft is using, needs a little bit more training to get the emotion correct. The age is not completely off, and it certainly gets the gender right though. So it is kind of accurate to what I'm feeding it. But you feel free to go back and try it out yourself. Use any of the AI demos that is on this site to get a sense for what artificial intelligence can do when used with Azure. Azure supports a large range of solutions for almost any kind of cloud product. For the exam, we went through 4 different kinds of solutions for Azure. Internet of Things is a network of millions of connected devices. Key is that the system functions without any human intervention. Azure products to create a managed and robust IoT solution include IoT Hub, a platform as a service offering to collate and assemble all your data feeds from IoT devices, and IoT Central. IoT Central is a software as a service product that comes with tons of prepared data templates and dashboards to make sense of your IoT data. Big data is processing of very large collections of data. Businesses want to use this to provide better service, better products, and ultimately be more competitive and profitable. Azure offers the Data Lake Analytics and HD Insights products to store, analyze, and make sense of big data. Cloud technology makes it feasible to analyze these vast data sets. For businesses, it can mean cost reduction, better decisions, and new products. Artificial intelligence comes with connotations of robots taking over the world, but on Azure, it's a lot more benign and useful. You use models to train an AI by having it play it over and over again. Usually put under the machine learning category, the main Azure product is the Machine Learning Studio and Machine Learning Service. The Studio has pre-made models and a range of tools to make using AI a little bit easier, and the Service is a range of tools that you can use to implement machine learning across your application in Azure. Serverless is an abstraction from servers. You are essentially using someone else's server. You learned about 3 serverless products. Azure Functions, which is a form of compute to run just a single function over and over again. Azure Logic Apps, which is a way to connect and integrate hundreds of different data feeds and applications. And finally, Event Grid, which is a network to pass events from application to application. The last solution we covered was DevOps, using 2 separate tools. First, Azure DevOps, which consists of Azure Boards, Azure Pipelines, Azure Repos, Azure Test Plans, and Azure Artifacts. You can choose to use one or more of these to streamline your DevOps processes. We also looked at Azure Dev Test Labs, which is a way to set up development and test environments easily and consistently using templates. Alright, another chapter goes past. See you in the next one. Managing virtual machines, infrastructure, and hard drives is so last week. So is there a way we can get rid of it all? Welcome serverless. Now we've covered serverless in a couple of other chapters in this course, but it is such an important part of modern cloud computing that we can do it again. First of all, serverless is, of course, not serverless. Serverless refers to the fact that you aren't managing any servers yourself at all. Your applications are running on someone else's server. Serverless is an extreme version of Platform as a Service, or PaaS, and means that Azure will manage all the services you use. Let's have a look at 3 serverless products from Azure to get a sense of how it works and which solutions it is appropriate for. The first one is Azure Functions. This is the original serverless product on Azure and gives the clearest idea behind the technology. It's called Function because the entire idea is that the service provides a single function to do a single task. There are no servers, no applications, no systems, just a single function. It is the most fundamental thing in compute, and Azure Functions will run your functions millions of times a minute or second if necessary. Logic apps are a way to connect many different and varied systems both within and outside Azure. You can integrate apps, data, systems, and services across enterprises or organizations. A logic app can schedule, automate, and orchestrate tasks, business processes, and workflows. For example, every time a tweet is made from an account, trigger some process. No coding skills are needed at all. All the connections and integrations are fully customizable in the Azure portal. So what does this mean in practice? For example, every time a new order is created in your ordering system, you can create a logic app that creates a record for how long it took. It inserts that into a database and sends an email to the person in charge. You can also have a conditional path, so if, for example, the order was over $100, you also send a different email to customer service asking them to thank the customer. You can connect a ton of different applications either manually or using templates. There is no code needed, no servers to set up, and you can get started very quickly. The last serverless product we'll go through is the event grid. But first, what is an event? In computing terms, it is when an application or process wants the world, being other connected applications, to know that something happened. It could be the placing of an order, for example. So when that order is placed, the ordering system raises an event. But how do you get that event to the applications that need to know? Well, that is what Event Grid is for. Think of it as a big network of connections to any service that wants it. You can connect most Azure products to it, and when they're connected, events are sent to Event Grid, from which connected services can receive the events. Event Grid is a routing service for connected applications, making sure events are sent and received fast and accurately. It's a serverless service because you don't manage any infrastructure. You merely sign up to use the service, which has a very specific and simple task. Well, simple in concept at least. Event Grid makes setting up complex architecture of interconnected, disparate services a lot simpler. Event architecture is not part of the scope of this course, but it is a crucial part of cloud computing usage. Serverless solutions on Azure are a major reason to use the cloud platform. Removing the need to manage servers and infrastructure and simply focus on the immediate task of solving a business problem saves time, money, and gets you to market quicker. This is exactly where A Cloud Guru started. Our illustrious leader, Sam Serverless Kroonenberg, built the initial platform in just 1 month. For the exam, remember these things about serverless. Yes, there are servers. They just aren't yours. Azure Functions are the most basic of compute services. Your function performs once, then dies. When a new request comes in, it wakes up and does it again. It does just one task. Logic apps connect systems and applications with ease, integrate applications inside and outside of Azure, using their data flows or service endpoints. Logic apps are a quick way to schedule and automate workflows and tasks. And Azure Event Grid is a routing service for passing events between services and applications. Events are messages that applications raise and that other applications need to know about. Next up, a short summary of Azure solutions. On the sharp edge of IT operations and development lies a wild west of processes, optimization, and efficiency. DevOps. You may have heard of the term DevOps before. It refers to the body of work between a developer finishing a feature or section of code to the product being in production and real-world users are using it. So how does the software get into the real world and how are processes for this created and managed? This is what DevOps is targeting. The term DevOps is a mix of development and operations, and I'd love to give you an official definition, but there isn't one. Tough luck. Instead, I'll offer you my own description of the term. DevOps is at its core about people, how developers, engineers, and system administrators organize themselves and work as a team to deliver better products faster. And in order to do this, Azure provides some tools and services that make this process easier. The first tool is Azure DevOps, which is actually a platform consisting of 5 different tools. And these tools are meant to work together to provide a smoother, more robust, and ultimately faster development of new products. There's Azure Boards to allow project managers to keep track of work tasks, timelines, issues, and plan the full project timeline for a team. Azure Pipelines is for producing and testing your software and applications automatically every time a change is made. Azure Repos is a secure and managed way to store all your source code for your applications. This is the magic juice to developers. Azure Test Plans lets you set up automated tests of your applications to make sure it won't break once users start using it. Your quality assurance team will thank you for this part. And then Azure Artifacts, which is a way to share your applications and code libraries with other parties on your team or externally. And it's free, well, to get started with Azure DevOps at least. And it is a platform that is part of an efficient and modern software product lifecycle. The second tool we'll cover is Azure DevTest Labs. Where Azure DevOps focuses on the software and applications, DevTest Labs focuses on the environment they run on. Through centralized management, DevTest Labs can allow developers and engineers to create their own brand new test environments. This all happens without incurring unexpected costs and at the same time minimizing waste of resources. You can even automate the creation of environments, which could allow test of applications and development to be even more streamlined. Azure DevTest Labs comes with a range of features to let you tailor each environment to your needs and set up templates to reuse environments over and over again. DevOps is an approach that is a fundamental part of modern software and technology development. All right, on to the next lecture. Security. The topic that causes much stress to business owners is sometimes not understood fully and a metric for any cloud provider. We're getting towards the end of the course, so it is probably about time we tie some of the topics together and focus on this most crucial part of not just Azure, but any computing project. In this chapter, we cover the following topics. Understand how you can secure your network connectivity using the built-in Azure tools and services. You can secure entire networks or just small parts of them depending on your architecture needs. Get an introduction to the Azure Security Center and understand how it helps you and guides you to a more secure Azure platform for your services. The Azure Key Vault is a brilliant service to keep passwords and secrets safe. The Key Vault uses secure hardware too to make it even more secure. To keep your emails, documents, and sensitive data secure, you will learn about Azure Information Protection. This clever service works even outside of Azure. And finally, the Advanced Threat Protection is used to identify suspicious user and device activity. You'd want to know when your application is getting unwanted attention. Of course, you won't become a security expert from just this chapter alone, but you will get knowledge of some basic security concepts you need to know for the exam. So here we go, securing things. Don't tell your passwords to anyone. But who can help you share it then, if you have to? Well, Azure Key Vault can. Now, one of the problems in information security today is that attackers know where to look for your passwords. They can get them from your customers, from the dark web, from other data breaches, and many more places. It is essential that businesses and people change their behavior for using passwords and secrets. Now, management of your secure keys and secrets is essential in any computer scenario, and Azure is no exception. Humans just aren't meant to remember multiple passwords, and you should never use the same password twice. Having humans remembering or storing passwords also lacks encryption and security. Even if you could remember the passwords, then you wouldn't want everyone to know them, even if they have access to your systems. Neither approach works, so what to do? Azure Key Vault is a secure place to store passwords and other secrets. You can then share those secrets with others without revealing the actual secret. Let's say you have a database with some valuable business data in it. While you use the data successfully internally, you also want to share access to other trusted outside third parties. However, you don't want to just give them the username and password to access the database. Instead, you place the password in Azure Key Vault and then provide access to individual applications. The application can identify itself, and then Azure Key Vault grants access to the database. The password is never sent to the application itself. So the Key Vault has some key features. Even if someone could get access to the Key Vault on Azure, the storage is done on hardware that is secure as well. Not even Microsoft can see or extract your keys in the vault. The application can't pass on the access to any other application, and access can be removed very fast in Azure Key Vault without having to change passwords. Of course, Key Vault can scale globally like any other managed Azure service, so you can get cryptographic high performance too. Next, we go from password protection to protection of email, documents, and other data. It is almost inevitable that any documents, emails, or other data you have will need to be shared with someone outside your organization. In this lecture, you'll learn how to use Azure Information Protection and how this can make this much more secure. When data is stored on company servers and resources, how do you really know who has access to your data? What if an employee has gone rogue and is taking the data? Competitors will most likely want your information, but how do you prevent that? Any organization will have to share documents, emails, and other data outside of the relative safety of the company walls. That is just the nature of doing business. In order to help companies secure their data regardless of where it is stored, Azure has the Information Protection Service, which works in conjunction with Office 365, Microsoft's online productivity suite, and this works in a number of ways. You can classify your data according to how sensitive it is. This can be done automatically according to policies or manually by users themselves. You can track activities on the shared data, and if you need to, you can even revoke the access to it. Sharing data with others become a safe exercise, and you are in control of who can edit, view, print, and forward which parts. Controls for protecting and classifying are integrated with Microsoft Office and other apps directly. That gives one-click securing of data and documents. For example, if Melanie has to send an email with a sensitive attachment to Tony, then she can use Azure Information Protection to secure that attachment. Melanie uses a label that is defined in Azure to tag the document and create a link to information protection. Every time a user opens it, the user is validated and the document is protected. Pretty neat. Next up, protecting against bad threats to users. If only there was a way to manage all the various security features of Azure. Oh, funny you should ask. There is! And it's called Azure Security Center. Now, information security is a complex field, and attempting to secure all parts of your system can be a real challenge most of the time. You often end up with multiple solutions you have to try and integrate to get a single unified view of your current security posture. It gets messy really fast. The Azure Security Center is a portal within the Azure portal. It alerts you to threats that Azure detects, and it helps you protect against them. The really cool thing is that this works in a hybrid cloud setup too. If you have virtual machines both on premises in your private data center as well as on Azure, the Security Center can monitor all of them. This works by each VM having an agent, a piece of software, installed on them that sends data to the Security Center. Azure then analyzes that data based on millions of previous machines on the platform and will straight away let you know if there's been an attack or anomaly detected. The Security Center highlights a few areas in particular. Policy and compliance are monitored by Azure, and the result is showed in the security portal. You get a secure score, which is a nice way to entice you to make your Azure implementation as secure as possible. Nothing like a bit of gamification. You can get security information from other cloud providers, such as AWS and Google Cloud Platform, directly into Azure Security Center using a Security Information and Event Management or SIEM tool. This provides a single point for any multi-cloud security information. If any of your VMs don't get updated with security and system updates, store encrypted data, have unnecessary public-facing endpoints, and much more, you'll get adequate alerts to fix it all. To take full advantage of Azure Security Center, you generally follow a three-step process. First, you need to define security policies that Azure can use to monitor your infrastructure. A security policy is a set of rules that Azure can use to evaluate if your configuration of a service is valid. Security Center comes with some predefined policies, but you will need to set up your own too. Second, you have to actively protect your resources. While Security Center limits your exposure to threats, you still have to actively monitor the policies and outcomes. And then third, if, or rather when, because it will likely happen, a security incident occurs, you have to respond to it. Security alerts will be raised by Security Center, and you will have to triage them. You can then investigate any of the alerts and adjust your Azure implementation accordingly. After all, what's the point of a Security Center if you don't pay attention to the alerts it raises? Using Azure Security Center is a must for any organization serious about their cloud security. Next up, we talk about secrets. Security is a major part of any infrastructure. Managers love hearing about how secure a solution is, so they don't have to worry. It is one of those areas that, if it isn't done well, everyone will eventually know about it. Not a desirable outcome. In this chapter, we first went through some tools to secure the networks on Azure. The first one was a firewall, which controls what data come in and out of a network. It does this with rules about the traffic. A DDoS attack is a lot of traffic from many different machines to a single point. Azure protects against this type of attack through its global network with no downtime to your application. And then finally, a network security group can be used to protect a single subnet or single virtual machine. The Azure Security Center is a portal within the Azure portal for you to monitor your security hygiene of all your Azure VM resources. You define policies, protect your resources more efficiently, and can respond to any incidents. Azure Key Vault is a secure way to share access to applications and resources with third parties without ever revealing any credentials. It scales globally, and not even Microsoft has access to the secrets in Key Vault. Azure Information Protection is a way to share files and data inside and outside of Azure and still maintain control over that data. You can control who views, edits, prints, forwards, and more. Finally, Advanced Threat Protection is a service to help you secure and manage users of your organization. Users are often the weakest link and are targeted by attackers. ATP will monitor users' behavior, create a baseline of this behavior, and report on any anomalies from it. You can then make changes to policies and procedures based on this. Feeling secure now? Well, excellent. So let's go attack the next chapter then. The last lecture in this chapter is for Advanced Threat Protection, which is more advanced than the standard one, obviously. Now, users in any organization are the heart of the business. The problem is that users are unreliable, whether they are internal employees or customers. And if these users have access to your organization's servers, documents, and other systems, then they might be a weak link for attackers. There is a constant threat to any infrastructure, and if you have anything of value, someone will probably want to get their hands on it. Yes, even dolphins. One way could be to target users specifically. Users are often the weakest link in an organization, and they can be tricked, coerced, and manipulated to provide details to assist attackers and to give them access to the corporation. Advanced Threat Protection, or just ATP, helps you monitor users in your on-premises environment and their behavior. Azure ATP analyzes user activity and information across your network, including permissions and membership for each user. ATP uses this to create a baseline for each user on what their normal routine looks like. If any user does something that is not normal, ATP will log it as suspicious activity. ATP will also suggest changes to meet security best practices where relevant. Profiling and analyzing users will help reduce the risk the user base poses, and you can make changes based on that. ATP will monitor several aspects of what is referred to as the cyber attack kill chain. Yeah, I know. Silly terminology, but it's what we got. That is, the ways that attackers can get into your systems. If a user is carrying out reconnaissance and searching for information about usernames, device IP addresses, and other activities that checks out the system, ATP will alert you of that. Identifying attempts to compromise user credentials using brute force, that is trying various combinations of a user's username and password over and over again. And any attempts to gain access to users with access to more resources and areas within the network. Azure ATP is a non-intrusive tool that helps monitor your user base and alert you to any change in their behavior. It gives you that extra layer of security and management of your users in order for your system to be more secure. Next, a short security summary. In this hands-on lab, we'll look at how to create an Azure Key Vault. And we're in the Azure portal. And to find the Key Vault, now you may notice on the left, for once, we don't have it as a favorite, so we need to find it. So I'll go up to search here, and I'll write Key Vault. And there you go, there are Key Vaults here. And in order to create one, you click Add, like most other resources in Azure. So we click Add, and that'll bring up the wizard for creating a new Key Vault. So we fill in our details like we have done before. So this will be Key Vault RG. We'll create a new resource group for us. We'll give the Key Vault a name. We'll call this ACG Key Vault. And we need to choose a region. Oh no, it's already in use. So let's call this ACG Unicorn Key Vault. Now it's happy. Very good. And we'll choose Australia Southeast, and our pricing tier will be standard. It is worth noting here, you can choose what's called a HSM-backed keys. This is a hardware solution that is inherently secure in the hardware, not just the software part of it. So you can choose that as well. And let's go next to the access policy. We're just going to have a look at this because the whole idea of using a key vault is to limit access to some sort of secret or password or something. So we need to have an access policy. We need to control who can access this key vault. I'm going to choose my user here. That's fine. I'm not going to enable access. I'm not going to change the default. I just want you to know that this is the idea of a key vault, is to have access policies to somehow control the access to this. So we're going to click Review and Create. It'll validate the selections that we have made, the default and the specific one. And our validation is passed, so click Create, and that will now create our Key Vault for us. And now our Azure Key Vault has been created, so we can go to that resource, as we have done before. And here's now our Key Vault. So let's add a secret to it. So on the left here, click on Secrets, and we can click on Generate to create a new secret. And there are two options. We can choose manual, or we can upload a certificate. So this could be for secure internet traffic, for example. Let's give it a name. I'm going to call this the ACG Unicorn Secret. And the value of this secret, of course, is 42. But you can't see that. But it says 42. And I can set an activation date, an expiration date, and I can enable it. I'll just click Create here. So what this does is that it now creates a secret in our Azure Key Vault called ACG Unicorn Secret. We cannot see the value of this, right? This is the whole idea. It's a secret. So if ever I need to share this secret, I will allow someone or something, a service, for example, access to the ACG Unicorn Secret, and they will then get the value out without actually seeing it. So they can use the value without me sharing what it is. And that's the kind of cool thing. So that's Azure Key Vault. It is a very, very useful tool for managing and sharing secrets with third parties and others that you don't want to share the actual secret with, but you do need them to have access to it so they can use one of your services, for example. Azure Key Vault, very cool. No one likes their data to be visible to everyone on the internet. I don't want my home address and personal card details in the public domain, for example. I want to be able to trust that my data is stored adequately and my privacy is looked after. Probably not a surprise by now, but Azure has services to do just that. In this chapter, we'll cover the following. Governance. What is it in the context of Azure, and why is it an area that must be done perfectly? Which tools does Azure offer to govern your instance of Azure much better? Azure Monitor is a collection of tools to let you detect, diagnose, visualize, analyze, respond, and integrate data from your Azure services, logs, and metrics. Downtime is about as serious as the world ending, at least if you ask any business owner. Azure Service Health can help you ensure maximum uptime and make everyone happy. Compliance is often an afterthought, but Azure makes it a first-class citizen. We check out how. Privacy is a fickle subject and everyone has an opinion on it. Azure tries to get the best of both accessible data and privacy in your applications. Azure has its own Trust Center, which Microsoft really wants you to read and hence get more trust in Azure. We'll take a look. Because cloud computing is your data running on someone else's server, there is a lot of focus on getting the right attitude and approach to privacy, compliance, and trust. So let's get started on the journey of cloud compliance with a little sprinkle of governance. The networks on Azure is what gives access to everything. All your services on Azure are connected to a network in order to communicate with users, processes, and other Azure services, which means we need to secure that network connectivity. For the exam, you need to understand certain products and ideas of how to secure Azure networks and their connected services. We'll start with the oldest and most common, the Azure Firewall. To explain further, let's cross to my reporter on the scene.
I'm here at the world-famous Firewall Bridge. This is the only access to the city behind it. So if the bridge is closed, no one gets in. And this is the same idea with a computer firewall. Unless you can cross the bridge, get through the firewall successfully, you cannot get into the town, well, or the Azure resources. So let's say this train here, or internet package, is trying to get into the town. Choo-choo! Oh, one of the rules, however, says that only black trains can get in, and this train is obviously blue. It's the wrong color. So it is denied access. The rule in the firewall denied this traffic. However, if I take this other train and put that on there, my other internet package, and it's black and it wants to cross the bridge, well, it's let through because it's a black train, it's the right color. The rule in the firewall allows this traffic. Whee! To ensure that only the appropriate trains are allowed access to the town, certain rules for crossing the bridge are set up. And that's the same in a firewall for a network. Certain rules in the firewall protects the network from traffic that is not allowed.
A firewall is a dramatic name for a proven and crucial service. It is a set of rules that decides whether network traffic is allowed to access the service or device attached to the network. Firewalls come in many versions and sizes, both in software and hardware incarnations, and for small, big, and huge networks. A firewall is a must-have part of any network that takes security serious. Next agenda on the network security menu is DDoS. But before we get into the details, let's take a look at history. Now in 2012, not one, not two, but but a whopping 6 US banks were targeted by a string of DDoS attacks. These are distributed denial of service attacks. The victims were no small-town banks either. They included Bank of America, JP Morgan Chase, US Bancorp, Citigroup, and PNC Bank. The attack was carried out by hundreds of hijacked servers, which each created peak floods of more than 60 gigabits of traffic per second. Then in 2014, security provider and content delivery network Cloudflare was slammed, literally slammed, by approximately 400 gigabits per second of traffic. The attack was directed at a single Cloudflare customer and targeted servers in Europe. And then finally, on February 28, 2018, GitHub, a popular developer platform, was hit with a sudden onslaught of traffic that clocked in at 1.35 terabits per second. If that sounds like a lot, that's because it is! That amount of traffic is not only massive, it's record-breaking. Now, all these attacks had severe consequences for the companies involved. They lost business, trust in their service, and had to spend millions of dollars to fix their systems. So, distributed denial of service. This is one of the most common attacks on services attached to the internet. But what actually happens? Imagine you have a website that is running on a server. This server can only serve or handle a certain number of requests every second. Let's say 1,000 requests. If too many users come into the site at the same time, let's say 10,000, at some point not everyone would get through. The server would try to serve all the requests for its content until it would fall over. At some point the server hasn't got enough resources and it simply stops. If this is done on purpose to take the server out, it is called denial of service attack. What often happens though is that the attack is distributed, meaning it comes from many different sources or computers. So a DDoS attack is lots of computers targeting a single server or website with the aim of making it stop. A famous DDoS attack was, as I said before, against the developer website GitHub in 2018, where attackers sent 127 million requests per second. That is a lot. To protect against DDoS, Azure has the DDoS Protection Service. This service has various levels of protection depending on what your needs are for your application. At its core, Azure detects the DDoS attack and deflects it away from your service. And this is done without any interruption to your application due to Azure's global presence. They can simply catch and mitigate the attack from anywhere in the world. Finally, at least for this lecture, there are network security groups. Think of these as personal firewalls for your resources. You can attach an NSG to any virtual network, subnet, or network interface, which is attached to a virtual machine. A network security group, often called NSG, is a set of rules for who and what can access any resource attached to the NSG. For example, if you have a virtual machine that is on a virtual network, the network can be behind a firewall protecting everything on the network, and then the VM can have its own network security group to define specific rules for just that machine. So everything is behind a firewall, but the VM has an extra layer of security, which is its own network security group. An extension of NSGs that can help you secure your Azure services is an application security group, where an NSG or network security group will protect and monitor traffic to a specific network or virtual machine. An application security group will, well, as the name implies, protect an application. This could be your Angry Lava website or Azure Function app. Application security groups let you configure your network security as a natural extension of an application's structure. You can group virtual machines and define network security policies based on your application and its components instead of using an explicit IP address. Securing your Azure network is a first line of defense against any unwanted visitors. Using a firewall, DDoS protection, or network security groups are just a first but important step. Next, let's talk about making sense out of chaos. Whenever Azure plans on performing maintenance or there is a service incident, also called a whoopsie, it would be great if you were notified. Well, you will be with Azure Service Health. The Azure platform needs to be updated and maintained just like any other computing infrastructure. While this is often done without you even noticing, it is important that you can mitigate the risk and take necessary steps to protect your infrastructure and applications. Downtime of your services and applications is the enemy. Downtime is evil. In Azure, there is the Service Health Dashboard right there in the Azure portal. Look at it. It's nice, isn't it? Azure Service Health notifies you about any planned and unplanned incidents on the platform. And the features include a personalized dashboard, like we just saw, in the Azure portal that shows the service issues that affect any of your resources. Custom alerts to notify you of any outages, planned or otherwise. These alerts are very simple to set up and part of the Azure platform by default. When an incident occurs, you can get the root cause of what happened, track the event in real time, and then download the official report afterwards. And it's a free service. That should be one of the first things you configure for any new resources that you create. That is really it. So next lecture is, well, it's right over here. Come on. Every service on Azure produces data as it performs its cloud duties. That data needs to go somewhere and preferably be used. Azure Monitor uses this telemetry to improve your Azure experience. Now, managing cloud infrastructure very often means lots of services, lots of individual processes, and lots of balls in the air. But you still need to be on top of the health of the whole system and monitor everything that is happening. When things run smoothly, that's fine. But what about if some resource is not performing 100% or another service has stopped altogether? This is the scenario Azure Monitor aims to solve. Before we get that far though, let's cover what telemetry is. The definition of telemetry is the collection of measurements of other data at remote or inaccessible points and their automatic transmission to receiving equipment for monitoring. Yeah, that's from Wikipedia. Don't judge me. Translated into normal speak, telemetry is information about how services or devices are performing. This information is passed to a central point for further analysis. In Azure, the telemetry all goes into Azure Monitor, which gives you this lovely dashboard in the Azure portal. The central point here is indeed Azure Monitor. For example, when virtual machines are running, Azure administrators need to make sure they are running smoothly the whole time. The second a VM isn't performing, you need to know. You don't need to know what data is on the VM or what it is transmitting. You need the data about the machine, the telemetry. This telemetry is fed constantly into Azure Monitor that collates and monitors it all. And this happens with most Azure services. They will feed telemetry into Azure Monitor. Even services you host on premises can feed telemetry into Azure Monitor. As I mentioned before, you can store and analyze all your telemetry in a centralized and fully managed location in the Azure portal, an interactive query language that you can use to query the telemetry data and learn about the data as well. Use machine learning to predict and recognize any problems with your resources. The outcome of using Azure Monitor should be maximize performance, maximize availability of your Azure applications, and identify issues before they even become problems. All things that we really like to have, right? Now, next up, some health advice. Privacy is an extension of compliance, and just like any other online business, you need to take privacy seriously, which is why Azure takes it very seriously. In Azure, privacy is such a core part of the platform that there isn't a single service or place for it. Instead, the built-in privacy controls include tools and services that are also covered in this course in other chapters. Azure Information Protection is used to classify, label, and help protect data based on its sensitivity. Azure Policy, which we covered earlier in this chapter, is used to define and enforce rules to ensure privacy and external regulations. When dealing with GDPR privacy requests, that is, requests from European users of your data, use the guides on Azure to comply with these requests. Use the Compliance Manager to make sure you are following the guidelines around privacy, such as GDPR and ISO standards. All these tools are available to help simplify your privacy compliance. And of course, Microsoft also has their own privacy statement. And because you chose to do this exam, you have to know about it. And that means I have to teach you as well. So thanks. Yeah. As with every other privacy statement on the internet, Microsoft explained how they're going to collect and treat your private data. Actually, it's so boring that I won't cover it here. But I've added a link in the resources for this lecture, so enjoy. Enough about privacy. It exists. It's important. Make sure you know about it. Next up, you'll have to trust me. What this entire chapter has built up to is obviously how much trust you have in Azure. Governance, compliance, privacy, and everything else are integral parts of trust in an IT system. There are two services on Azure that has to do with trust. The first one is the Trust Center. This is a shortcut to learn about all the things Microsoft does to make sure you don't lose trust in Azure and other Microsoft services. There are links to learn about security, privacy, GDPR, location of your data, compliance, and more. The links all take you to other Azure websites that can tell you more about the security implementation, privacy dedication, and so on. The other part is the Service Trust Portal. This is the location to review all the independent audit reports about Azure. It is their portal of proof that they're complying with a million different standards and certifications. It's crucial to know that Azure complies with all of the various quality and security standards. In fact, more than any other cloud provider, but you don't need to know which. That is what you can look up in the portal. If you want to read some audit reports on a Friday night, just for laughs, the Service Trust Portal is a great hangout. The short of it is, Azure really wants you to trust their platform, because without trust, there is no Azure. Coming up shortly is a trustworthy, brief, compliant summary. In this hands-on lab, we're going to look at Azure Monitor and how you can monitor the current health of the Azure platform. So we're back in the Azure portal, and to get to the monitor, as with a lot of other services, on the left under favorites, there is a monitor link there. So click on that, and that'll give you an overview of the monitor. The monitor is meant to monitor your applications and your infrastructure, as it says there right on the screen. You get lots of logs and data that comes out of services that then gets fed into the monitor, and you can then view those. In this lab, we're going to focus on the service health part of Azure Monitor, which is located right here. So click on Service Health, and this will show any current service issues on the Azure platform. So are there any outages? Are there any issues that you need to be aware of? Currently, you can see this says no service issues found. If there were any, they would show up on the map, the little world map there, and they would show in the list showing what is actually happening. What is the outage? What is the service issue? You can also click on planned maintenance. So Microsoft would tell you if there's any planned maintenance events coming up for Azure, and there isn't. Currently, you can see there is no maintenance events that are scheduled, but you could get a list of those so that you could take precautions and measurements to make sure that your services won't be affected by this. If we go back to the main monitor overview here, if you want to play around with this and see the logs and analyze any of the data that comes into it, you could create some services just as you can find in any of the other labs in this course, like a virtual machine or an app service. Those would feed data into the Azure Monitor, and you could then view this data and see how it works, but it is not the scope of this lab. But that's one option for you to get further with Azure Monitor. Regulations, legislation, rules, and guidelines are all things you need to adhere to, follow, and implement. If you don't, you get in trouble, which is why compliance on Azure is so important. And we start in Europe. If companies within the EU don't take compliance seriously, they can face massive fines, as you can see here. For example, if a company that is dealing with European customers don't comply with privacy regulations about personal data, they can be fined 4% of annual global turnover or 20 million euros, whichever is greater. That is serious cash that can hurt a company. And that is just one example of why compliance is important. So let's talk about industry compliance. It refers to the legislation and rules the industry in general has to comply with, and we're going to cover 3 of those. First off is the most well-known term, mainly because you probably got 2,394 emails about it, GDPR. The General Data Protection Regulation is significant. The main objective of the GDPR is to protect individuals with regard to the processing of their personal data. It is giving control of the data back to individuals instead of the companies owning the data. It also forces companies to put a lot of measures in place to protect the data and provide tools to users for managing that data. ISO is the International Standardization Organization, and they have a lot of different categories of compliance. Generally, it is compliance with quality and customer satisfaction, which is the ISO 9001:2008 certification. Great name. There are also other ISO standards for compliance, including food safety management and environmental management. NIST, or NIST, is the National Institute of Standards and Technology. Where ISO covers many industries and standards for a range of professions, NIST focuses purely on tech industry, in particular on information security frameworks for US federal agencies. The NIST guidelines are developed in such a way that compliance with NIST often ensures compliance with multiple federal US regulations. One of the most popular NIST frameworks is the cybersecurity framework. Okay, let's look at a tool to help you ensure compliance on Azure, the Azure Compliance Manager. Because Azure knows about the various compliance rules, and because it knows about your resources, Azure can combine the two and give you recommendations, and it does this through the Azure Compliance Manager. The benefits of using the Compliance Manager are, as I just mentioned, you get recommendations for how to ensure or achieve compliance with GDPR, NIST, ISO, and many others. This could be a missing secure component to your database, for example. Assign tasks for compliance to your team and track progress on them. Each team member can be responsible for a certain compliance area, and you can keep track of it with Compliance Manager. You get a compliance score to chase that perfect compliance. Nothing like a bit of gamification to get the team going for total compliance. A really cool feature is the secure storage, where you can upload compliance documents. If you have one of the compliance bodies giving you a document to prove you're compliant, then you can upload it to the Compliance Manager as proof. Of course, you can get a plethora of reports to satisfy managers, auditors, regulators, and whoever else needs access to your compliance data. With some idea of what compliance is, who makes compliance guidelines and frameworks, and how Azure can help you manage it all, let's look at two specific Azure regions and offerings that are unique when it comes to compliance. First is the Azure Government Cloud. If you're a US government body or you are a contractor for one, you can get access to Azure resources in the Azure Government Cloud regions, which are separate dedicated data centers. As you might imagine, the US government agencies have stringent requirements to compliance. Using one of the dedicated government cloud regions gives you some dedicated space to do this. Using one of the dedicated government cloud regions gives you exclusivity. You're guaranteed that only US federal, state, local, and tribal governments and their partners have access to this dedicated instance with operations controlled by screened US citizens. Compliance with all required bodies for US government agencies and Level 5 Department of Defense approval, which is better than 4, obviously. All the cloud benefits of using Azure in general, high availability, scalability, managed resources, and much more. Azure Government Cloud is one of those services that is reassuring government agencies that public cloud services are indeed a viable option for them. The second specific region when it comes to compliance is China. As a country, China has very specific and strict requirements when it comes to data, internet, and online entities. Therefore, if you want to use Azure to provide cloud services in China, you have to use China region in Azure. This makes sure that your Azure resource instances are physically located in China with no connection to any other Azure regions. All of your customer data is kept inside China at all times. This also means that services like Cosmos DB won't work on a global scale when China is included as a region. You are completely compliant with all Chinese regulations. The physical data center is even hosted by a Chinese company to ensure this. Another kind of heavy lecture, as anything including legislation and regulation tend to be. Non-compliance can bring about huge fines and problems, and compliance is not negotiable. For the exam, you need to comply with the following. See what I did there? Yeah? GDPR, ISO, and NIST are regulations and standards designed to protect consumers' privacy and also ensure you are compliant with relevant legislation. Azure has tools to help you be compliant too. Azure Compliance Manager can help you in your compliance journey. It gives recommendations to ensure compliance. You can assign tasks to team members, get your compliance score, store documents securely, and get lots of reports. Delicious reports. The Azure Government Cloud is a number of dedicated data centers purely for US government bodies. It ensures compliance with US federal, state, and local government requirements. Azure China region is fully contained within China. Both data centers and all data are within the country's borders and isn't connected to any other Azure regions. It complies with all applicable Chinese regulations as well. Next up, we are very, very private. If you give developers and Azure users too much freedom, it can really quickly end in resources that are incorrectly configured, not aligned with the business, or just cost too much. The solution to this is Azure Governance, and to explain it in more detail, here is my own personal bureaucrat.
What is governance? Well, let me explain using this rocket. Yeah, I like space, so a rocket it is. A rocket like this needs new components, new parts, adjustments, fixes, and upgrades, all in order for the overall goal of making it fly to be achieved. If every one of these engineers were to just replace the parts they thought, upgrade components that they deemed necessary, and added new features, well, chances of a successful launch would be a lot smaller. This is the same on Azure. If all developers and system administrators just did what they thought best at the time, you could end up with a real mess of way more resources used than needed, the wrong VMs created, and so on. What is needed is governance of the process. Governance on Azure is a set of rules, policies, and roles to define acceptable use of Azure resources. With our rocket here, it would inform the engineers which parts they could replace, which materials to use, who to inform of changes, and more. On Azure, it would restrict users from creating certain resources, what action they could do with existing resources, and any permissions for the Azure account in general.
As you can tell from that, governance is crucial. Azure has several tools and services to help you implement adequate governance of your Azure resources. The first is Azure Policy, which, as you may have guessed, is used to create policies in Azure. As the first sentence for the Azure Policy documentation states, governance validates that your organization can achieve its goals through effective and efficient use of IT. In other words, use Azure Policy to make sure users don't make a mess of it. A policy is a set of rules to make sure that standards and agreements within your corporation are followed and that resources are compliant with these policies. Look at it this way. If you have a bunch of Azure resources, you then also have a bunch of Azure policies defined for those resources. Azure Policy, the service, is what ensures that the resources are complying with the policies. Azure Policy is your enforcer. The next part of Azure Policy is a fundamental part of how you use Azure. Role-based access control, often called RBAC, is a critical component in governance of users and their access to Azure resources. Role-based access control lets you define which users have access to specific Azure resources, what they can do with those resources, and what areas they have access to. One of the best practices for any computer infrastructure is to give users the minimum access they need. If a user doesn't have to access a database, well then don't even give them access to it. It keeps users out of trouble, and RBAC can enable this. That means you can target specific use cases for assigning access. For example, allow an application access to only the resources it needs, or allow a user access to all resources in a specific resource group. RBAC works through assigning roles to users, and a role assignment has three elements. A security principal, which is an object that represents what type of entity can get access to the Azure resource. This could be a user or a group of users, for example. A role definition is a collection of permissions. A role definition lists the operations that can be performed, such as read, write, and delete. Scope is the set of resources that the access applies to. This is useful if, for example, you want a specific role assignment to have only access to a specific resource group. Role assignment is the process of combining those three properties to grant access to Azure resources. For example, let's say you have three virtual machines called Admin, Billing, and General. If you want to create role-based access to these resources, you could do it like this. An admin role, this has access to all three VMs with all permissions. An accountant role, which can access the Billing and General VMs, it has read-write access to the Billing VM and read access to the General VM. And finally, a standard user role, and this has only read access to the General VM. The advantage is that you can now assign each role to any number of users. If there's a change to any of the roles, you only have to perform the change to the role, and all the users that have that role assigned will automatically get the updated role permissions. A simple and efficient tool to manage changes and removal of resources are locks. You might want to ensure that a specific resource will not be changed or deleted, which is what locks are for. A lock can be assigned to a subscription, resource group, or resource level. A lock can be of type delete or read only. Delete means you can't delete the resource, and read only means you cannot make any changes to that resource. Once a lock is assigned to a resource group, or subscription, it has to be removed completely before the actions are possible again for that resource. The first half of this lecture focused on helping with governance for users to enable them and also keep them out of trouble. We are about here now. The last part of the lecture on governance is looking at how you can make sure your Azure resources are both consistently created, deployed, and updated, as well as secure. Now remember, governance is here to keep you out of trouble. Now the first tool in this second half of the lecture is Azure Blueprints. As you may have guessed from the name, blueprints are templates for creating Azure resources. It is a blueprint for everything you need to deploy for a standard cloud environment on Azure. Think of it this way. If you had to create a brand new Azure environment for a new product, and you had to meet certain governance rules and regulations, how would you do that manually? Most likely, you wouldn't, as it would drive you to insanity. Instead, Azure Blueprints pack everything you need, including templates for which resources to create, user permissions using RBAC, and any necessary policies, all in one easy package. There are even built-in samples for the most common scenarios, including samples for scenarios with specific government regulations and guidelines. The last service for governance on Azure we'll go through is the Azure Advisor for Security Assistance. But here's the good news. While Azure Advisor is a separate blade and a separate portal within the Azure portal, the Security Assistance part of it is the same as the Azure Security Center, which is covered in the chapter on security, which means we don't have to do it here. Win! Instead, let's focus on some exam tips. Azure Policy is a platform tool to ensure that any policies applied to resources are compliant and let you know if they aren't. A policy is a set of rules to ensure that resources are compliant with any regulations and internal guidelines applicable. Role-based access control, or RBAC, ensures compliance of users by defining user access to resources. This is done through a security principle, a role definition, and a scope. Locks can ensure resources are either not deleted or not modified. They can be assigned to a subscription, resource group, or resource. Blueprints are templates for creating standard Azure environments that are compliant with a certain set of rules and policies. And the Azure Advisor, the Security Assistance part, is a part of the Security Center. Phew, some lecture. Governance is a bit dry. Even the word governance sounds kind of like sand in a dust storm. But it keeps you out of trouble. A lot. Alright, next, go! This chapter contains some of the really heavy and dry topics that you have to know about for the exam. So let's quickly recap them for your memory's sake. Governance on Azure uses several tools to make it easier. Azure Policy ensures compliance with assigned policies. Role-based access control gives access to users through roles that consist of a security principle, a role definition, and a scope. Locks can efficiently ensure resources aren't changed or deleted. Azure Blueprints are templates to create standard compliant environments. Azure Monitor collects telemetry data from resources for you to analyze and use. You can maximize performance, maximize availability, and identify issues. Azure Service Health notifies you about any planned and unplanned incidents on the Azure platform. Compliance comes in many flavors on Azure. You get tools to adhere to GDPR, ISO, and NIST rules and standards. You can use the Azure Compliance Manager to manage compliance for all your resources, and you can use Azure Government Cloud if you're an US government body, or China region to comply with Chinese regulations. Privacy on Azure is a core part of the platform. It is built into many products and services. Azure Information Protection, Azure Policy, and the GDPR Guide are some of the tools available. Finally, there are two destinations for learning about trust on and in the Azure platform. The Trust Center, where Microsoft tells you all of the things they are doing to keep your trust in the platform, and the Service Trust Portal, which showcases the audit reports and compliance certificates awarded to Microsoft and Azure. Wow, what a chapter. And you know what? There's another one. It comes with free cake. Here on the home stretch of the course, we've got to talk about the basis for a lot of decisions. Money. Yep, pricing is a definite part of any cloud computing conversation, and Azure is no exception. We won't go too much into pricing, but there are some important areas you need to be familiar with, and they include subscriptions. This is the basic part of managing Azure billing, and where the first layer of access control can be implemented. We cover billing cycles, access control, management groups, and more. Cost management, how do you make sure you don't get unexpected invoices and costs accrued? How much can you do with free accounts, and what are the tools to help manage costs? What are the factors that affect pricing, and how do you calculate estimated costs? What is the total cost of owning a specific Azure resource or collection of many? And then we round up with the chapter with some best practices in Azure for managing costs. Azure has tools to help you stay within budget and not get nasty surprises in the mail. Well, email. Now, before we get into all that pricing fun and shenanigans, let's cover first how pricing is structured on Azure. The whole premise of cloud computing is that you only pay for what you use. When you buy your own server and place it in a data center, you're unlikely to use the server 100%. You don't have to pay a monthly fee to use it, but you pay a large upfront cost just to get it, and you don't use it to its full potential either. You also have to pay for utilities such as power. On Azure, and cloud computing in general, you don't own the hardware, but you pay for access to it. On Azure, the price can be made up of one or more of the following: the number of hours you're using the resource, such as a virtual machine, the size of the service. A more powerful VM is more expensive than a basic one, and the tier or level of that service. A hot tier SSD storage is more expensive than the archive tier. And finally, the location of the service. A VM in East US is cheaper than one in Australia East, for example. So with that in mind, let's get into the next lecture. At the root of every invoice is the subscription. Can't live without it, can't hide from it. In the chapter on authentication and authorization, I covered subscriptions in the context of users and Azure Active Directory tenants. This lecture focuses on the pricing and billing side of subscriptions. Every resource on Azure lives within a subscription. Because Microsoft likes to be paid for you using their Azure services, and a subscription is how they send you an invoice, there cannot be a service or resource that lives outside of a subscription. Now, you can have multiple subscriptions for any Azure account though. This is really useful to organize and orchestrate who pays for what. It could be that different departments pay for their own cloud computing spending, and if they get their own separate invoice, that makes it simple. You'll often have a user in your organization that has the role of billing admin. This role is specifically in charge of the charges to the Azure account and can manage everything to do with billing and subscriptions. Using this role ensures that users that aren't billing admins won't have access to billing information. This creates a nice separation of responsibility for your organization. And finally, billing cycles on Azure are usually monthly and requires payment within 30 or 60 days. At any given time, Azure has a lot of active offer types. An offer type is, this type of subscription that you can get. While the most well-known is either pay-as-you-go or an enterprise license agreement, there are many more. It could be a BizSpark type for the new startups, a student account, or the one that I have for being a Microsoft Most Valued Professional or MVP, the Visual Studio Ultimate with MSDN. Check out the offer types available when you sign up for Azure. A very useful feature on Azure when it comes to subscription management is the use of management groups. As the name indicates, you can group your subscriptions to allow taking actions in bulk across subscriptions. This is especially useful when your organization has a lot of subscriptions. You can manage access, policies, and compliance in multiple subscriptions at the same time. For example, you could have a management group per country, per subsidiary, per department, or something else that makes sense in your scenario. This means you can still have the billing logic implemented, meaning resources are paid for from the right budgets, but the management of the subscriptions is hugely simplified. You can also nest management groups to indicate a hierarchy. Each management group can have a single parent group, but many child groups. Speaking of management, next up, some cost management. If there's one thing that most people looking at cloud computing offerings can agree on, it is this: pricing is very tricky to predict and calculate. Any Azure account can have a lot of resources: networks, connections, virtual machines, firewalls, storage accounts, functions, and the list can get very long. You'll have resources connected to each other, and quickly you lose track of how many dependencies are between various services. Then, try and calculate which pricing is valid where and how much it'll be. Impossible. Now, before we look at how to calculate Azure costs, let's start with establishing what has an influence on the price of a service. We start with the resource size. This is probably not a surprise, as of course different sizes of resources will have different pricing. Otherwise, we would just, create the biggest and most powerful of everything. A more powerful virtual machine will cost more than a less powerful one. A storage account with more space will cost more than one with less, and so on. The choice of resource type has a big influence on price. This also makes sense as there is a very big difference in the amount of hardware resources needed to run a virtual machine compared to a machine learning service or big data analytics. And there is also a big difference in the complexity of maintaining and running various Azure services. A less obvious influence on price is the location you choose to host the service. Azure has a global network of data centers from East US to Australia and Norway to South Africa. And they aren't all created equal, so they come with different pricing. Exchange rates also have an influence on this, as each location is affected by local pricing. The least obvious cost, and likely the hardest to predict, is the bandwidth needed. How much data are you going to have coming in and out of Azure? To complicate things, Azure has 3 billing zones in the world as well. Each of these zones include many Azure regions. Any data transfer between Azure services located in the same zone is free. Any data transfer between 2 different billing zones is charged. This is also called ingress, data in, and egress, data out, data. Ingress data is always free, but egress data, so that's data going out, has a cost with it when it is transmitted between 2 different billing zones. Yeah, complicated. All of these factors don't make it any easier to predict, but luckily Microsoft has provided the Azure Pricing Calculator. The calculator would estimate costs for almost any scenario you can think of. You can add any Azure service and it'll show in the calculator complete with any features that affect the pricing. If you add a virtual machine, you can select the size, location, operating system, and tier. If you add a functions app, you decide on the memory, number of executions, and execution time. Once you've added up all the different services you think you'll need, Azure will give you an estimate on the monthly costs of the services. Bear in mind though, it is only an estimate. You can export the estimate into a spreadsheet and use that as part of any proposals you might have as well. Knowing what the Azure monthly cost will be is great, but it doesn't answer the question of whether you'll be better off in the long run compared to having your own infrastructure. To cut up that pineapple for you, Microsoft has created another calculator, the Total Cost of Ownership Calculator, which is this gorgeous thing here. It's lovely, isn't it? This calculator lets you get an estimate of the total savings you could get for moving your on-premises servers, storage, networks, databases, and much more. In other words, how much can you save for using Azure instead of your own infrastructure? You can do this by entering as many details as you have or want to find, then estimating over a period of up to 5 years. And as you can tell from the screenshot, there can be significant savings. This is of course to showcase the costs of saving on Azure, but also to give you a report you can take to whoever makes the decisions and show them how much money can be saved. Maybe you'd even get a free plant for the office cubicle. Next up, some brilliant practices. The best! Running services and resources can be an expensive exercise, no doubt about that. But there are ways to manage this cost using, well, cost management. To explain further, let me introduce you to my resident accountant, me.
In front of me is Clintville, just up from the Firewall Bridge, a small town that is super conscious of their spending. Running a whole town can of course cost a lot of money, just like running a company's whole infrastructure on Azure. The lights in the streets needs to stay on, the garbage has to be collected, and roads, obviously that's a road, needs to be maintained. Some of these costs stay very static, or they're very easy to predict, such as turning on the streetlights. We know when that's needed. Other costs are more variable, such as paying for repairs to public playgrounds. It is the same on Azure. Some applications will run at a constant pace and costs are both predictable and long-term. Some virtual machines, for example, are only needed infrequently when demand dictates. Just like in a town, you need to know what your running costs are for cloud computing. If you don't have the right budget, the lights suddenly won't turn on, or your VM is deactivated. We need some form of cost management both for the town and for Azure. And this is a single place to track costs of many different areas. You need this to be automated, as you can't possibly keep track of every single cost. There's a lot. This is exactly what Azure can do for you.
You will have to buy services on Azure, as that is kind of how it works if you want to use them. But what's the best way? There are a few different ways that you can manage cost in Azure when buying services. First of all, there are free accounts. Yes, really free, as in not pay a thing. And free accounts include a range of benefits. After all, Microsoft wants you to try as many services as possible, so you're more likely to become a paying customer. At the time of recording, you get 12 months free access, which includes 750 hours of compute time on virtual machines, 5 gigabytes of storage, 250 gigabytes of SQL database, 5 gigabytes of storage on Cosmos DB, and a bunch of artificial intelligence services. There's also a large number of always free services such as Azure Functions up to a certain threshold, Event Grid up to a certain threshold, certain container services, load balancers, advisory services, and much more. Now, if you get a first version or prototype of your product done within those confines, then your Azure usage can start out being, well, completely free. You will need a valid credit card to sign up for a free account, as there may be costs after the first 30 days. Also, you can only get one free account per Microsoft account, which boils down to, well, an email address. So once you're using Azure, there is of course also a way to manage your costs. And you can guess what it's called? Yep, Azure Cost Management. Simple. And it looks like this, with a lovely dashboard to visualize your spending. Now, Azure makes it easy to create thousands of cloud services, but it also means it is just as easy to lose track of all of them and how much they cost. Azure Cost Management is accessible from the Azure portal, and you can get a detailed view of the current and projected future costs of all the Azure resources that are within your area of accountability. The tool is included with Azure usage completely free of charge for all subscription types. You can download reports on spending, get recommendations on how to save costs, and analyze costs in great details. And you can get the cost management tool to optimize your current resources to save you money. And you can even monitor your AWS spend in the tool as well. This is very useful for your multi-cloud setup. Managing costs on Azure is critical, and there are often ways you haven't thought of where you can save and optimize, which is why the cost management portal is so handy. Next up, we delve more into how pricing on Azure works. We've gone through how to use the cost management, how to limit user responsibilities using subscriptions, and how pricing works and can be estimated. This lecture looks at some of the best practices for keeping on top of your Azure spending. So let's start with spending limits. Accountants and budget-conscious managers really like this feature. Most Azure accounts has a number of credits every month, and the spending limit is applied by default. This could be $0 for some free accounts, or it could be $150 for a Microsoft subscription, for example. When the credits run out, the spending limit kicks in and stops use of any resources that would incur a cost. You can't increase the spending limit to, let's say, only spend $100 over the credits. The limit is when your credits run out, and then you'll have to remove the spending limit entirely for either the current billing period or completely. Certain Azure subscriptions, such as Pay-as-you-go, doesn't have any spending limit functionality. Some resource types on Azure have quotas. Quotas are limits on certain properties of the resources. For example, for event hubs, you have a maximum of 100 namespaces per subscription, 10 event hubs per namespace, 32 partitions per event hub, and so on. These quotas are set to ensure that Azure can service you adequately for any setup within its boundaries. For some services, such as virtual machines, you can ask Microsoft to change the quotas for your account if they are too restrictive. Expect to pay more for that though. Managing costs for Azure resources can be overwhelming and confusing, which is why there are a lot of tools available that we've gone through in this chapter. A simple yet efficient way to manage where each resource belongs is using tags. Tags are non-functional labels you can attach to each resource, group, or resource. You can name the tags anything you want and attach as many to each resource as you wish. However, some common best practices for using tags are these. You want to identify which roles can access what in order to protect sensitive data. You want to identify related resources for bulk automation processes. You want to filter resources used for projects, a specific customer, or for reporting. And when you use tags, make sure each is unambiguous for its use. For example, make a list that defines these properties for each tag. A description, define what each tag should be used to identify. A tag name, the exact term used for the tag, for example, department or project. And values, list out all potential values for each tag name to give you an idea of how it could work. Using a pay-as-you-go model on Azure is very common, as you only pay per month for what you use. However, it is also one of the most expensive options for Azure usage. You pay a premium for making little commitment to the Azure platform. If you are in it for the long term, and you have some idea of what you need on Azure over the next year or more, there are lots of bananas, dineros, dollaroos, and hard cash to save by using reserved instances of Azure services. It works like this. Hey Azure, I'd like to reserve some virtual machines for my use for a period of time. Certainly, sir. Would you like 1 or 3 years? I'm thinking 3 years. Awesome, here's 70% off. Reserved instances are available for a small selection of Azure services and products in particular virtual machines. Use them and you save. The last tool in implementing some best practices for managing your Azure costs is the Advisor. We've covered the Advisor tool before in this course, as it is also used for security and resource optimization, but it also has a cost optimization section. The Advisor portal gives you best practices advice in general through recommendations. For cost optimization, this could be a recommendation to scale down a virtual machine, removing networks you aren't using, and storage that is dormant. So those are the best practices highlighted by Microsoft to save you some cash. Next, a priceless summary. Pricing, the thing we can't avoid on Azure. Getting pricing right is key to keeping budget masters happy and Azure services rolling. Every resource on Azure belongs to a subscription. Each Azure account can have multiple subscriptions. A billing administrator manages everything to do with subscriptions and billing, and use management groups to group subscriptions and manage large number of subscriptions. Manage costs on Azure by using free accounts and the free services they include. Use the Azure Cost Management portal to get recommendations and optimize current resources. The factors that influence the cost of an Azure service include resource size, resource type, location of the service, and bandwidth and zones used. Microsoft provides 2 calculators to help you manage the costs, the Azure Price Calculator and the Total Cost of Ownership Calculator. Finally, the best practices for managing price and cost on Azure includes spending limits to ensure you don't go over your monthly allocated credits, quotas to ensure Azure performance and stability and to save you money, tags for keeping track of where resources belong, and reserved instances to commit to a 1 or 3 year use of some Azure services. Yes, cloud costs can be hard to manage and keep track of, but Azure has a lot of tools to help you out. Use them. There are a lot of parts to Azure, as I am sure you have realized by now, and it is impossible to be the master of them all, no matter how much you use Azure. There are always changes being made, improvements implemented, and new products introduced. And that is why there is an extensive support infrastructure for Azure and its users. In this chapter, we go through some of the most prominent support areas that you need to know for the exam. The various support plans that you can purchase and benefit from. These include various tiers and inclusions. What are support tickets and how do you create them and submit them? What are the available support channels? If you don't have a specific support plan, which other ways can you get support from Azure? We have a look at the Knowledge Center and some of the types of information you can find there. And what are the service level agreements and why do businesses pay big money to have one? And how do service life cycles work on Azure? There are private and public previews of services, general availability, and more. Support on Azure is a service that is make or break for some companies, and you need to know how it works as part of preparing for the exam. While it might not be the most glamorous part of the platform, it is important to ensure customers get the most out of it. Azure support is that link between newbies, efficiency, and world domination. In this lab, we're going to take a look at the pricing calculator and how that can make it a lot easier to figure out how much Azure services are going to cost. So the pricing calculator is an online tool and it looks like this, and you can find the link to it in the resources for this lecture as well. Let me just scroll down a little bit here so we can see the entire, there it is, the entire calculator. So it works by adding the services and the products that you would like to use and get a price for. So let's add a virtual machine. We just click on it. It takes a second, and then the virtual machine is being added, and we can click on the view link here that comes up, and that scrolls the page down to look at the virtual machine. We then need to choose some basic properties for this virtual machine, such as the region. Let's choose Australia Southeast. Operating system, Windows is fine. Type could be, what type of server you want. And then you can choose a pricing tier as well, depending on the priority that you want the virtual machine to be on the Azure infrastructure. And of course, we need to choose a size. And because this is a calculator, we can choose any size we want that is available in this region. So let's scroll down and we're going to choose a monster virtual machine. This one here. which is $47 an hour, but also has almost 4 terabytes of RAM and 128 virtual CPUs. It's a pretty big one. And then if we scroll down a bit further, we get an estimate for how much this will cost. This virtual machine being used for 730 hours a month will cost $34,912.98 US, which is a fair chunk of cash. So this shows you, yes, you can have a very, very large virtual machine that can do a lot of processing, but you will also pay for it. We could also say we only need this an hour a month for some very, very high intensity task, but it won't take that long. So we can change this to 1 as well. And it'll again cost us $47 a month. If we can remember to turn it on and off, this might be a good option to process some very, very large job very quickly. Okay, let's add one more service. Let's add an Azure function. Instead of clicking view, I can scroll down here. You can see there's our virtual machine, and then further down, the Azure function has been added as well. So this we need to choose a region for. We can choose Australia Southeast again. And then, as it says here, at the time of recording, the first 400,000 gigabits a second of execution or 100,000 executions are free. So we could say that we want more execution time than that in seconds. We'll say 100, and we're going to have how many executions? 4 million executions a month. So now suddenly there is a price attached to this Azure function. So as you enter your details of how much you expect to use the services, the calculator will give you an estimate of what that will cost. So let's scroll down a bit further. We can also choose our support level, and let's say we want a standard support tier included in this service that we're building. That will cost us $100 a month. And then we can see down the bottom, this estimate is going to cost us $942.08 US a month. And of course, we can change the currency to whatever it is that your local currency is. You can also export it, and you can save it, and you can share it around to whoever needs to know about this estimate. You can spend a lot of time on the pricing calculator. There's a lot of options. All the services in Azure can be priced up according to what you think they will, what you'll need from them, and you'll get a cost based on that. The pricing calculator can take some of the mystery out of using Azure and the cost associated with it. To contact Azure support, you use the medium of tickets. Tickets are what the inquiries you make to support are called. A ticket is usually a number that uniquely identifies your inquiry. All communication and details of your support requests are recorded with the ticket number attached to them, so there is a single reference to the whole support request. You submit a ticket through the Azure portal, which means you have to log in first to the portal. You choose whether the issue is of type billing, service and quotas, subscription management, or a technical issue. Choosing this correctly is critical to getting the right service promptly. Depending on which type of ticket you are creating, you are asked to add additional details about the issue. And once you submit a ticket, a Microsoft support person will attend to your request within the specific times that we went through in the previous lecture. The more you pay, the higher a support plan you get, the faster you have your issues attended to. Remember, the basic free support plan only allows you to create tickets to do with your subscription and billing. Nothing technical. That's it. It is simple to create a ticket, and you can get help quickly. Next, let's look at other ways to get technical help. There are more ways to get help on Azure through the various channels available. There are multiple ways of learning more about Azure and getting support than you might think. People learn in very different ways, so there is a way for pretty much everyone. Let's start with the Azure documentation, which is free to everyone. The Azure documentation is a collection of thousands of articles written by Azure product managers, technical experts, and contributed to by the community as well. They are constantly updated and give in-depth knowledge and use of all Azure services, tiers, variations, and products. The various forums attract everyone from beginners to experts, where questions are asked and answered, ideas proposed and validated, and architecture decisions scrutinized. As an added bonus, you can search through the forums as well to see if someone has already asked the question you have. Some of the forums are linked in the resources for this lecture. As vague and opinionated as social media can be, it is also a great way to get direct support from both Azure as a team and the individuals that build and design the services. Of course, the rest of the community is there as well, such as me. Yep, you can find me and lots of other Azure professionals on Twitter, LinkedIn, YouTube, and many more places. Any of these channels can be used at your leisure, depending on what kind of interaction you prefer. Haha! Another short lecture! Onwards! If only there was a central location for the common Azure knowledge. Oh yeah, there is! The Azure Knowledge Center. When you're just starting out with using Azure, which I'm guessing you are since you're taking this course, there might be a lot of questions that are basic, which is totally fine. Having questions is good because that means you're interested and want to learn. Shout them from the rooftops. Exactly. However, because you're just starting out, many of the questions you might have will be similar to what other new cloud enthusiasts have as well. And that is why the Knowledge Center exists, to answer common Azure questions. You can't ask your own questions or add to the knowledge base of the center, but you can search for any questions you like. Some of the answers will be right there in the Knowledge Center, and some will be a link to the Azure documentation. You can search by category or product on Azure and browse the answers. If you can't find an answer to your question, then use one of the channels I mentioned in the previous lecture. Check it out using the link in the resources for this lecture. And next up, we discuss some agreements about service levels. To find the right level of support for your organization, Microsoft offers various support plans that you can subscribe to. There are 5 different support plans available in Azure: Basic, Developer, Standard, Professional Direct, not just Professional, it's more direct apparently, and Premier. Choosing the right plan is a balance between how much access you need to help and support, and at what turnaround time, and how much you are willing to spend. Microsoft compare them on a range of areas to make it clearer which is right for you. And guess what? You have to know this. Yep, so here we go. There are a few things that are included with all support plans. These are 24/7 access to billing and subscription support. Microsoft wants to make sure you can pay them, of course. Online self-help, which includes the rather excellent Azure Online documentation and white papers are guides on complex issues or scenarios. Support forums, which are often a great way to ask other users what they use and how they do things. A Cloud Guru even has a support forum for this very course that you can use for questions regarding the course. Best practices recommendations from Azure Advisor. See other parts of this course for details on the Advisor service. And access to service health status on how Azure is doing. And those things are included with all support plans free of charge. And incidentally, that is also the entire range of features for the basic plan, which is free as well. So let's look at Developer, Standard, Professional Direct, and Premier. Depending on how much cash you're willing to part with, each level has more comprehensive support in the following areas. Technical support. Developer get business hour support via email, and the rest get 24/7 support via email and phone. Every level receives guidance and troubleshooting on configuration of Azure services. Their response time dramatically decreases the more you pay. Minimal business impact, that's severity C, goes from 8 to 4 hours as you go up in the tiers. Moderate impact, that's severity B, has no response time on developer support because you don't get any moderate impact support, and goes from 4 to 2 hours on the others. Critical level, that's severity A, response time is available from the standard tier and is always less than an hour. You can get architecture support that ranges from general guidance to architectural guidance to customer-specific support, design reviews, performance tuning, and implementation assistance from Azure experts. Professional Direct and Premier get even further services too. They get operations support in the form of onboarding services and reviews, to technical reviews and reporting, and even a dedicated technical account manager for Premier. And then training comes in the form of webinars and on-demand and proactive guidance. Apart from Premier, these service tiers can all be signed up to online, and your support service starts immediately. Now next, anyone up for a ticket? This chapter on support for Azure covered a bunch of ways you can get help and support from both Azure and the community. There are 5 different support plans, which are Basic, Developer, Standard, Professional Direct, and Premier tiers. The more you pay, the more support and more benefits are included. Higher tiers also have lower response times to resolving issues. A ticket is a unique reference for a support issue. You create tickets through the portal when you need assistance. Use the various channels for getting more support from Azure and the community. There is the Azure documentation, Azure forums, and social media avenues that can help. Use the Knowledge Center to get answers to common Azure questions. Each product and service on Azure has a service level agreement that outlines a contract between you and Azure, documenting Microsoft's commitment for uptime and connectivity. Services on Azure can be in private and public preview stages before being generally available to all Azure customers. Also, keep an eye on the Azure Updates feed for news on products, features, and more. And that was it for this chapter. I reckon there's only one more to go. Nearly there. Every product and service on Azure has a start in life called the service lifecycle. Think of it as the natural birth of an Azure service. When services are developed by Microsoft for the Azure platform, at times it can be necessary to ask the customers, the actual people that will be using the service, for help. Customers can provide valuable feedback about features and functionality before everything is set in stone and before Microsoft has made a large investment into that product. There are three main stages in the Azure service lifecycle. We start with previews. By far, most of the Azure products will go through a preview phase before becoming full-grown adult Azure services. Some services start in a private preview stage, and this means that an Azure feature is available to specific Azure customers for evaluation purposes. This is typically by invite only and issued directly by the product team responsible for the feature or service. Some features then go to a public preview or start directly in this stage. Public preview means that an Azure feature is available to all Azure customers for evaluation purposes. These previews can be turned on through the preview features page in the Azure portal. Finally, there's general availability. You've probably guessed it, but it means an Azure service is generally available to all Azure customers. The service has an SLA, a support team, and anything else that goes with an adult Azure service. A service will go into general availability when the product team behind it decides it is ready. There's no specific time period for any of these stages. Also, the rollout to general availability can happen gradually to some regions first, before going fully global. If you want to know when a service enters either preview or general availability, or when new features are added, you can monitor the update feed from Azure. This feed is updated very often and gives a single view of every change and new feature on Azure. It is also linked in the resources for this lecture. Next, some summarizing coming up. You're at the end! Yes, there is no more Azure content to cover, which is probably a good thing. So this last chapter is all about the exam and beyond. We'll cover a comprehensive exam overview for what happens on the day, what types of questions can you expect, how is the exam structured, and much more. Some next steps for what to do after you complete the exam for Azure Fundamentals, and then a short introduction to some of the regular news we provide from A Cloud Guru called Azure This Week. It's a very short chapter, this one, so let's get into it. In this hands-on lab, we're going to look at some preview services and how you can use them in Azure. I am now in the Azure portal, but it is not the standard Azure portal that we've been using for the other labs in this course. This is the preview portal. You can see up the top left, it says preview, and it is at a different URL or a different web address, preview.portal.azure.com at the time of recording. You can also find the correct link in the resources for this lecture. This preview portal will give you a preview into all the features that are coming out for the portal. So not Azure services or products themselves, but the portal as a product. You can log into this with your existing Azure account, your free account that you've just created for this course, and you will get access to it like anyone else will. So let's have a look at what's in here. It looks slightly different. The portal menu is, in this case, looking a little bit different, but it should all be relatively familiar to you if you've used the portal before. So let's go into our virtual machines, and it should look very familiar again from the lab that we created a virtual machine in. Now, one of the things that you can also do is finding preview products or preview services. So let's go up here to the search, and we're going to search for Bastion, which is currently a service that is in preview for Azure at the time of recording. So here are Bastions. Bastions is a way of using virtual machines, and it's a new feature that is still in preview, which means that it hasn't been released to general availability. But in the preview portal, you can see how that would work inside of Azure. So you could add a new Bastion if you wanted to, and that would take you through the whole wizard as it currently stands and is likely to look when it is launched into general availability. So this is the familiar wizard that you have seen before, and that would then take you through the flow of creating a new Bastion. So any of the preview features that are in public preview, you can access either through the preview portal if you want the portal experience, but you can also access most of them through the standard portal, but you just don't get the portal preview part of it as well, if that makes sense. So the portal is a product itself that you manage your Azure products with, and that has a preview version, and each of the services and products may have a preview version as well. So that's how you can play around with what's coming next on Azure. When you use an Azure service, you want some form of guarantee that the service will be running and that it's stable. That's what service level agreements help ensure. And to explain the idea of service level agreements, allow me to introduce my multi-personality colleague.
A service level agreement is a contract between a service provider and a client. Here I have a lamp with a switch. When I turn the switch on, I expect the light to turn on, obviously. This is the same on Azure. When I click that button in the Azure portal, I want the service to react. If you set up a virtual machine to perform a job, you expect it to do so until you stop it. Back to the lamp. Let's say I flick the switch and the light doesn't turn on. Ooh, problem. How do I know when the light comes back on? How do I even know they're fixing the problem? And even worse, how can I do any work when it's all dark? Obviously. Equivalent on Azure, how can you do the task the virtual machine is supposed to do if the VM isn't on? Now, a service level agreement is a contract with the power company or Azure that states how long the power can be out or the service down. It is an agreement on a certain level of service you can expect. It could be an agreement that power can only be up for 5 minutes every month, and when the power goes and the light doesn't turn on, a stopwatch starts. And if that goes over, say, 5 minutes, you are entitled to compensation. It is the same on Azure. If a service is not working for more than an agreed period of time in a month, you can claim compensation from Microsoft. You pay for an SLA, which is what service level agreements are often called, to ensure the least possible downtime of a service. It's like insurance. If there's a breach of the SLA, you can claim.
To reiterate, SLAs are key in ensuring customers have confidence in the uptime and availability of Azure services. SLAs ensure there is a contract between you and Azure documenting Microsoft's commitment for uptime and connectivity. There are a lot of SLAs in Azure, at least one for each product. And when you sign up to Azure and start using a product or service, the SLA for it automatically comes into effect. Some SLAs can become very complex as they can have various levels depending on how many instances you run, how large they are, which region they're hosted in, and much more. It isn't always as simple as, my virtual machine was down for 5 minutes, now give me some cash. SLAs are given from Microsoft and isn't something you choose. If you're using an Azure service, you have an Azure account, and then you can take advantage of the SLA for any paid product you're using. In general, there is no SLAs associated with free products on Azure, which kind of makes sense because you can't really claim money back from something you haven't paid for. Almost through the chapter. Next lecture, go, go, go!
The world of cloud computing moves at a pace that makes the stream of new features, services, and products plain dizzying. And Microsoft Azure is guilty as charged. At A Cloud Guru, we have made it our mission to keep on top of what happens in Azure, and because we love the cloud and our students, every week we recap the best Azure news. Azure This Week is made specifically for cloud professionals, enthusiasts, and everyone else that wants to keep their finger on the cloud pulse of Microsoft servers in the sky. The show covers large announcements, small feature fixes, opinions on platforms, and it's all sprinkled with terrible attempts at humor. Excellent humor, obviously. The show is free on the A Cloud Guru platform and is a great bite-sized way to keep up with the latest in Microsoft Azure. So see you there for all things Azure.
Once you've passed the exam, then what? Well, Azure Fundamentals is just that, the fundamentals. There's more to do. Now that you have a taste for cloud computing, where do you go from here? There are several directions within Azure that target different professional roles. Starting to learn everything in details from the onset would be overwhelming, right? So after completing Azure Fundamentals and the AZ-900 exam, I would recommend focusing on mastering the basics of using Azure day to day. This includes the portal, the CLI, setting up simple scenarios of various services, and more. The labs on A Cloud Guru are short 5 to 10 minute lessons that focus on doing just one thing, like creating a virtual machine or storage account with PowerShell. The labs are a great way to start getting your hands dirty and using Azure in a practical sense. Also, click all the buttons, in the proverbial sense at least. Explore the various services and get familiar with how the structure of the services is designed. A lot of Azure services work in similar ways. The labs and exploring will give you more exposure to Azure, and that will give you an idea of what kind of direction you might want to pursue. The two main directions are infrastructure and development. Infrastructure is all about managing resources, setting up networks and virtual machines, making sure the infrastructure as a service services are running smoothly, and configuring access to your Azure platform. You can find links to infrastructure courses in the resources for this lecture. Development is launching websites, implementing security solutions, troubleshooting issues on Azure, connecting to Azure services from your own applications, and using the platform as a service offerings on Azure. And you can also find links to development courses in the resources for this lecture. Cloud Guru also has projects, which are longer courses that go through creating a practical project from start to finish. You get to learn the quirks and best practices of real Azure services and use cases. Oh, and they're really great fun, as the projects take a slightly unconventional approach to the topics. I hope to see you soon in another course on the ACG platform on your journey into Microsoft Azure.
Congratulations! You've made it through the entire course! Unless of course you skipped parts, did you? You're now almost ready to take the exam and get your certificate for Azure Fundamentals. If you haven't had the chance to, I highly recommend practicing with the chapter quizzes. Also, if you come across any helpful advice or have questions, please go straight to the course forum. You might find some advice for yourself there as well. The community of students for each course on A Cloud Guru is an important part of your success, and it provides like-minded keen people that you can draw on for help and experience. So if you have any suggestions, please go there to provide any feedback you might have. I will actually read it, I promise. So once you've passed the AZ-900 exam, you can start applying what you've learned in your workplace. If you're ready for your next certification, I recommend studying either AZ-103 or AZ-203. There are also many other areas in Azure, including development, infrastructure, or another Azure-based course. Chances are that you will find all of them on the A Cloud Guru platform as well. So from me, have a great learning journey, and I hope to see you again soon. Keep being awesome, Cloud Guru.
I had a lecturer once at university that always claimed the day of the exam is a day of joy for the well-prepared. And no matter how you feel about exams, this course will prepare you for the best way to pass that exam. Now, before we get into the exam details, here's a disclaimer. A Cloud Guru does not control nor have any influence over the Microsoft Azure exams. The information in this lecture is based on what Microsoft has publicly revealed about the exam and our general understanding of it. Microsoft may change the format, length, or any other aspect of the exam without notice. Of course, we'll do our best to stay current with any changes though. So, what can you expect on the day? Let's start with some numbers. You'll have 60 minutes to complete the exam. This time doesn't include any load time of questions or any other times where you can't work on the questions. You'll go through roughly 44 questions in total, which gives just about a minute or a little bit more per question, which is adequate for this exam. The types of questions you are asked will vary. Standard multiple choice, so that's 3 to 6 options, generally about 4, mix of both single answer and multi-answer. Questions will have one or more correct answers, which will be stated at the time of the question. A statement with an underlined part, you have to decide if the statement is correct or swap it with the option. You're provided with 4 options, where one is no change required. Drag and drop, where you, for example, select 3 out of 7 options and then reorder them in the correct order. An image with hotspot areas, you'll be asked to click on the right area of the image. This could be to identify a service in the portal, for example. True-false questions for the same problem. There are 2 types of these. One has several separate questions, presented one at a time. Once you answer a question, you cannot go back. Most of the information remains the same, you just have to pick whether the proposed solution is appropriate. The second type has 3 true-false answers on the same page for the same question. At any time, you can go back and review a question, except for the first 6 questions. Because they're of the type of multiple true-false for the same question, you can't review those once you've answered them. If you want to review a question later in the exam, you can mark it for review. There can also be questions on the exam that aren't marked. These questions are there so Microsoft can test new questions. The exam is broken up into 4 parts that count towards your final score. Understand cloud concepts, which is 15 to 20%. This is chapter 1 and 2 of this course. Understand core Azure services. This is 30 to 35%, and this is chapters 3 through 9 in this course. Understand security, privacy, compliance, and trust. This is 25 to 30% of your mark, and this is the chapters 10 and 11 in this course. And then finally, understand Azure pricing and support, which is 20 to 25%, and this is chapters 12 and 13 in this course. As you can tell from that, there's a lot of knowledge that can be tested for core Azure services, but it's still only a third of the mark. That's just how it is. You can do the official practice test from Microsoft as well. It is linked in the resources for this lecture, but it does come with a cost. It isn't free. Once you're ready to sit the exam, which is now, right? You can choose from 2 ways of sitting it. At a local test center, this is a public institution available for delivering your exam. You book into your preferred location through the online booking tool. At your home or office, online proctored exams allow you to conveniently take an exam in the comfort of your home or office. This does mean you have to confirm compatibility of your microphone, webcam, and bandwidth. You have to clear your workspace completely, and no one else can be present in the room while the exam is in progress. And once you've finished the exam, you'll get the result straight away. No waiting around for days. Immediately, you'll know if you failed or passed, including your score for each of the 4 areas. You'll need 700 points out of 1,000 available to pass the exam. This isn't exactly 70% though, as you don't know how much each question is worth. But at least it's something to keep in mind. When you pass the exam, it'll be recorded on your official Microsoft Learning profile. You'll also get access to an official certificate and official virtual badges with AZ-900 on them to share on your social media profiles. If you do fail the exam, don't stress. You can take any Microsoft exam up to 5 times in any 12-month period. There's a 24-hour mandatory wait to take an exam the second time and 14 days mandatory wait on subsequent attempts. Now do let us know if we've missed anything, because Microsoft do change their mind from time to time. Use the forum for the course to get the best response from one of the experts on the ACG team. Coming up next, what to do after the exam. In this hands-on lab, we'll go through how you sign up for an exam to take a Microsoft certification. I'm on the website for the AZ-900 exam, and as well as having all the details of the exam, the outline and so on, it also has a part here that says schedule exam. So first choose the country that you are in or you would like to take the exam in, and then that will give you the price in that country. Then you click the big yellow button that says schedule exam. That will then use your Azure account or your Microsoft account to log in to the learning platform, and you can then fill out the details that you need for the exam. And I'll fill out all the various things here that I need to fill out in order to be a valid entry. Phone number, and please put in your real phone number. And then the language of the exam, there are many. Often you'll only have one choice in your country. In Australia, you can only take exams in English. And then you click I have read and agreed to the terms and conditions, and then you save and continue. Make sure you have the right legal name, that you put your actual legal name, because at the exam center, you will have to prove your identity. And that will usually be with a photo ID. So yes, that is, I am Mr. Lars Klint. I accept that. And then that gets saved and you get taken to the next step. There are 2 separate areas here. If you're a Microsoft employee, you can link that ID. Or if we're not, we just complete the registration by continuing to Pearson's, which is the training provider and the exam provider. You need to select your exam delivery option. So at a local test center, so that would be near you in your city or near where you are. At my home or office, this is an interesting way of doing it. You can take the exam at home, but you will need to be, there's a bunch of criteria. You need to be alone. You need to not leave the room for the entirety of the exam. You need to have a high quality webcam and connection. And there will be a proctor, a person that you need to show your entire room with the webcam, everything. You cannot have any books, any material near you. And there's a lot of other criteria that you need to comply with so that you have the exam, the same environment as you would have at a local test center. I'm going to choose local test center, click next. And then in this case, I have 4 different languages that I can choose. I'm going to choose English. So there you go. You can also choose other languages in Australia, as it turns out. And then, yes, that is the exam I would like to take, and that's the price and the language. And I go, yep, I would like to schedule this exam. And then I need to find test centers near. So I'm going to type in Melbourne and click search. Yes, I meant the city of Melbourne in Australia. And then I can scroll down and I can see which training providers are available within the Melbourne city or the area around Melbourne. I'm going to choose the advanced training location and then click next. And I can now choose a date. So I'm going to choose, say, the 29th of October, and it'll give me a list of times that I can choose here. So you can choose your time. I'm going to go with 3 p.m. And here's my order, which is the exam. Tuesday, October 29, 3 p.m. Location in Melbourne, $99. I can add some available products here if I want to have the official practice tests for either of these two exams. And then I can proceed to checkout, so $108.90 US. And there's another check here. Again, the name must exactly match what is represented on my, say, driver's license or other photo ID. It's very important, otherwise they will not let you sit the exam that day if you can't provide that. I have to agree to all their policies. Please do read these policies because they're important on the day. When to arrive, what to bring, what not to bring, what you can expect. Once you've read that, you need to say you've read them. You click next. And then it comes to payment details. You need to put in your payment details, a valid credit card to pay for this, and some billing information. Obviously, I'm not going to schedule the exam right now because I have already set it, so it wouldn't let me. But you go through this, you put in your payment details, and you will be sent a confirmation email and a receipt. And then you go to the test center on the day and sit your exam.